Hello there. Welcome to the Science Owl Station channel. Today we are going to drift across the vast, white expanses of our planet, journeying into the quiet heart of the cryosphere. The frozen water that shapes our world, preserves our history, and holds the secrets of deep time in its crystalline grasp. Imagine, if you will, a landscape where the chaotic noise of the modern world simply does not exist, where the air is so crisp and pure that it feels like breathing in starlight, and where the only sound is the ancient, settling groan of ice that has been waiting for you for 1,000,000 years. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I would also love to know where you are joining us from tonight, and perhaps what time it is in your corner of the world. There is something profoundly comforting in knowing that while we are separated by distance, we are connected here in this shared moment of calm. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. To understand the frozen world, we must first shrink ourselves down, smaller than the snowflakes drifting past a window pane, smaller than the dust motes dancing in a sunbeam, until we reach the very architecture of silence itself. Everything we see in the realm of ice, from the towering glaciers that carve valleys into mountains to the delicate frost that patterns a leaf in autumn, begins with a subtle, invisible shift in energy. It is a story of slowing down. In the liquid world, water molecules are frantic travelers, tumbling over one another, sliding and colliding in a chaotic, energetic dance that never ceases. They are driven by heat, by the vibration of existence. But as the temperature begins to drop, as the warmth of the sun retreats and the shadows lengthen, a profound change takes hold. The frantic dance begins to languish. The molecules, once so hurried, find themselves heavy with the cold. They move with a newfound deliberation, a sluggish grace that mimics the onset of sleep. This is the first secret of the cold. It is not an addition of something new, but the quieting of energy, a descent into stillness. As the thermal energy dissipates into the ether, the water molecules are no longer able to overcome the attractive forces that exist between them. They are drawn together, not in a collision, but in an embrace. This is the hydrogen bond, a delicate magnetic whisper between the oxygen of one molecule and the hydrogen of another. In the warmth of liquid water, these bonds break and reform billions of times a second, fleeting and unstable. But in the cold, they become permanent, rigid, and structural. Here, in this microscopic cooling, a miracle of geometry occurs. As the molecules lock into place, they do not pack themselves tightly together as one might expect of a solid. Instead, they arrange themselves into a hexagonal lattice, a six-sided crystal structure that is as airy as it is strong. This is the paradox of ice. In almost every other substance in the universe, the solid form is denser, heavier, and more compact than the liquid. But water is unique. Water is a rebel. As it freezes, it expands. The molecules hold each other at arm's length, creating vast, open spaces within the crystal lattice, filled with nothing but silence and emptiness. This open architecture makes ice about 9% less dense than liquid water. It is this singular, atomic quirk that allows ice to float. Imagine the consequences if it did not. If ice were heavier than water, the oceans would freeze from the bottom up, locking the deep currents in a tomb of solid cold. likely ending life as we know it before it could even begin. Instead, the ice forms a skin, a floating shield that sits atop the water. It becomes a thermal blanket. When you look out over a frozen lake or the vast expanse of the Arctic Ocean, you are seeing a protective barrier. Beneath that jagged white surface, the water remains liquid, insulated from the biting wind and the sub-zero air by the very ice that formed from it. Life continues in the dark, warm depths, safe beneath the floating architecture of the hydrogen bond. There is a deep, resonating beauty in thinking about this expansion. When the world freezes, it takes up more space. It claims its territory. You can hear this claiming on a cold winter night when the temperature plummets and the trees in the forest crack like rifle shots, the sap inside them expanding, pushing against the wood. You can see it in the heaving of the soil, the way the frost lifts heavy stones from the earth in a slow geological exhalation. It is a powerful, relentless force, born from the simple act of molecules aligning themselves into hexagons, deciding that they need space to rest. This structure, this hexagonal lattice, is the foundation of every glacier, every iceberg, every polar cap. It is a cathedral built of water and cold. When we speak of deep time, we often think of rocks and strata, but ice has its own memory, its own way of counting the centuries. The ice does not just sit there. It waits. It captures the atmosphere of the past, trapping tiny bubbles of air within those open spaces of the lattice. We will explore these archives later, but for now, just hold the image of that lattice in your mind, billions upon billions of hexagons, stacking perfectly, locking together to form a solid surface where there was once only fluid motion. The transition from water to ice is a phase change, yes, but it feels more like a sigh. It is the universe exhaling its energy and settling into a state of rest. There is a specific temperature, 0 degrees Celsius at standard pressure, where this decision is made, a threshold between the chaotic and the ordered. But in nature, things are rarely so binary. The process of freezing is often a slow creeping, a colonization of the liquid by the solid. Needles of ice shoot out across the surface of a puddle, long, thin fingers grasping for purchase. These are the dendrites, the tree-like structures that seek to bridge the gap between one side and the other. They grow not by force, but by invitation, as water molecules surrender their heat and join the lattice, one by one, click by click, in a silent molecular Tetris. Consider the clarity of this newly formed ice. When the freezing happens slowly, when the water is calm and the cold is gentle, the lattice forms without interruption. The result is black ice. Not actually black, of course, but so perfectly transparent that it reveals the darkness of the deep water or the asphalt beneath it. It is invisible, a phantom solid. It is only when the freezing is rapid, or when air is trapped, or when the structure is fractured, that the ice turns white, scattering the light in all directions. But at its heart, in its purest form, ice is a window. It is a lens through which we can view the suspended animation of the world. As we drift deeper into this frozen realm, let us appreciate the stillness that the ice brings. It acts as a dampener. Just as the open spaces in the crystal lattice hold the molecules apart, a layer of snow and ice dampens the acoustic vibrations of the world. Sound travels differently here. It is muffled, softened, absorbed. The sharp edges of noise are filed down, leaving only a hushed reverence. This is why a snowy landscape feels so incredibly quiet. It is not just the absence of human activity, but the physical presence of the ice itself, swallowing the sound waves, hoarding the silence. We are standing at the precipice of a journey that will take us from this microscopic geometry to the colossal weight of continental ice sheets. But it all starts here with the hydrogen bond, with the slowing down of the dance, with the water molecule deciding to stop, to expand, and to float. It is a small act of defiance against the crushing weight of gravity, a lightness born of cold. It is the first breath of the winter, the foundational silence upon which all the frozen cathedrals of the earth are built. High above the earth, in the silent, suspended gray of a winter sky, the story of a glacier begins not with a roar, but with a microscopic act of gathering. It begins with a single speck of dust, a tiny particle of clay, or perhaps a grain of volcanic ash that has drifted on the stratospheric winds for years. This is the seed. In the cold, thin air, where the temperature hovers far below freezing, water vapor, invisible and ghostly, wanders until it meets this seed. And there, in a moment of pure serendipity, the vapor bypasses the liquid state entirely. It sublimates directly from a gas into a solid crystal. This is the birth of the first flake, the genesis moment of the frozen world. As the crystal forms, it remembers the geometry of the water molecules we spoke of before. It remembers the hexagon. From the central nucleus, 6 tiny arms begin to sprout, reaching out into the supercooled air like the spokes of a wheel. This is a process of slow, deliberate construction. If you could watch it happen, suspended there in the clouds, you would see the invisible air knitting itself into a solid form, layer by molecular layer. The arms grow, branching off into intricate fern-like patterns called dendrites. The symmetry is maddeningly perfect, a testament to the order that underlies our chaotic universe. But here is where the story becomes personal for the snowflake. As it grows heavy enough to fall, it begins its long, drifting descent toward the earth. This journey is what defines it. As the flake tumbles through the atmosphere, it passes through layers of air with slightly different temperatures and varying levels of humidity. Each layer acts as a sculptor. A slightly warmer pocket of air might cause the tips of the arms to blunt and widen. A dry, cold patch might encourage sharp, needle-like growth. Because the snowflake is spinning, all 6 arms experience these changes simultaneously, maintaining that beautiful radial symmetry. However, no 2 snowflakes follow the exact same path through the turbulent sky. Their histories are written in their shape. To look at a snowflake is to read a map of its descent, a crystalline record of the specific atmospheric conditions it endured on its way to the ground. Gravity gently pulls it downward. The fall is slow, almost reluctant. A snowflake has a low terminal velocity. It floats more than it falls, caught in the updrafts, dancing in the eddies of the wind. It is a lonely journey, yet it is happening to billions of flakes simultaneously. They create a veil, a curtain of white that softens the horizon and blurs the sharp lines of the landscape. The world below is waiting. When the snowflake finally lands, it does so with a silence that is absolute. It settles onto the cold ground, perhaps on a rocky outcrop, or perhaps on the back of a previous flake. It locks into place. This is the moment of accumulation. Alone, a snowflake is fragile, ephemeral. It can melt on the tip of a warm nose or vanish in a breath of sunlight. But if the conditions are right, if the ground is cold enough, if the summer that follows is cool and short, the snowflake survives. It does not melt. It remains. This is the second secret of the glacier. It is made of survivors. A glacier is, in essence, a fossilized winter. It is a collection of snows that refuse to bleed away into the rivers. As the first flake is joined by a second, and then 1,000 more, and then 1,000,000,000, a blanket begins to form. This blanket is soft, composed mostly of air trapped between the delicate, spiky arms of the crystals. It is the most pristine white imaginable, reflecting nearly all the sunlight that hits it, keeping the world beneath it cool. Imagine standing on a high mountain plateau or near the polar circle as this accumulation takes place. The snow deepens. The familiar contours of the land, the sharp rocks, the dips in the terrain, are gently smoothed over. The world becomes a study in soft curves and undulations. This is a landscape in the process of being erased, buried under a falling sky. The silence deepens with every inch of snow. As we mentioned, the air pockets within the snow absorb sound, creating a hush that feels thick and physical. In this silence, time seems to detach itself from the ticking of the clock. Seasons pass. The winter ends, but the snow remains. The sun rises higher in the sky, but its heat is reflected away by the brilliant white surface. Then the next winter arrives. New clouds form, new seeds are found in the upper atmosphere, and new flakes begin their descent. They fall upon the old snow, burying it. The layer from last year, the year of the first flake, is pushed down. It is covered by the fresh history of a new winter. This process repeats over and over with a rhythm as slow as the orbit of the Earth. Year after year, century after century, the layers build up. The snow at the bottom, the snow that fell when your great-grandparents were children, or perhaps when the pyramids were being built, or even when woolly mammoths walked the tundra, is buried deep in the dark. It is no longer touching the wind or the light. It is being held in the crushing, protective embrace of the snow above it. We are witnessing the transformation of weather into geology. The transient, fleeting nature of a snowstorm is being converted into something permanent, something with weight and mass. The atmosphere is being solidified. Every layer of this growing pile contains a snapshot of the world at the time it fell. The dust that acted as the seed for those ancient snowflakes is still there, trapped in the lattice. The pollen from flowers that bloomed 10,000 years ago is there. Even the chemical composition of the air itself is preserved in the tiny spaces between the crystals. This accumulation is not a static pile. It is a living history book, growing thicker with every storm. But for now, the snowflake we followed, that single intricate star of ice, is just beginning its long slumber. It has landed. It has survived the summer. It has been covered by its brethren. It is no longer an individual. It is part of a collective. It has entered the deep time of the cryosphere. It rests in the dark, under the weight of the new world pressing down upon it, waiting for the pressure to begin the next stage of its metamorphosis. The delicate arms that once danced in the wind are now locked in the stillness of the pack, holding their breath, waiting to become something harder, something clearer, something blue. The accumulation continues, flake by silent flake, painting the world in white, one microscopic crystal at a time, building a monument to the cold that will last for millennia. As the seasons turn above, wheeling through their cycle of long, sunlit days and endless twilight nights. The snowflake we followed, that delicate, six-armed star, begins to change. It is no longer touching the wind. It is no longer free to drift. It has been buried. The accumulation of subsequent winters, layer upon layer of fresh snow, presses down with a weight that is gentle at first, but relentless. We are entering the realm of the subsurface, a world of increasing density and profound darkness, where the only active force is gravity and the slow, inevitable march of time. This is where the magic of fernification begins. It is a word that sounds soft, almost like the material it describes. Firn is the intermediate state, the bridge between the fluffy, ephemeral snow of a winter morning and the hard, blue steel of a glacier. Imagine the snowflake deep within the pile. The pressure from above is heavy, like a thick wool blanket that never lifts. Under this weight, the fragile, intricate arms of the crystal, the dendrites that once reached out to capture moisture in the clouds, begin to break. They shatter. The sharp points are ground down, not by violence, but by the sheer crowding of billions of other crystals all vying for the same space. The snowflake loses its identity. It becomes a grain. It becomes rounded, granular, like a coarse sugar or wet sand. This is Firn. It has survived one summer's melt, and now it is preparing for eternity. In this state, the snow is still porous. There is still air between the grains, a network of tiny, winding tunnels that allows the atmosphere to breathe through the pack. But as more snow falls on the surface years and decades later, the weight increases. The pressure builds. The grains are squeezed tighter and tighter together. At the molecular level, something miraculous is happening. The ice grains are sintering. Without ever melting into liquid water, the molecules migrate. They move from the convex parts of the grain to the concave hollows where the grains touch, bonding them together. The contact points grow, these are called necks, and the grains fuse. The ice is knitting itself into a solid fabric. It is a slow-motion welding, driven by the cold and the weight of the world above. As this compression continues, the air tunnels are cut off. The pathways that once connected the deep ice to the surface are squeezed shut. The air that was circulating, the breath of the world from the year the snow fell, is trapped. It is pinched off into tiny spherical bubbles. This is a pivotal moment in the life of the ice. It is the moment the door to the outside world is locked. The air inside those bubbles is no longer part of the modern atmosphere. It is a time capsule. It contains the exact ratio of oxygen, nitrogen, and carbon dioxide that existed when that layer was formed. It holds the dust of ancient volcanoes, the pollen of long-dead flowers, perhaps even the chemical signature of a Roman lead smelter or the ash from a prehistoric fire. This transformation from snow to firn, and finally to solid glacial ice, is not a quick process. In the high mountains where the snowfall is heavy, it might take a few decades. But in the dry, frozen deserts of Antarctica, where the snow falls as a fine, diamond dust, it can take centuries. 1,000 years might pass between the moment a flake lands and the moment it is sealed off as true glacial ice. 1,000 years of slow, crushing settling. The ice is now becoming a rock. We often forget this, but ice is, geologically speaking, a mineral. It has a crystal structure, a specific chemical composition, and physical properties just like quartz or feldspar. And like a sedimentary rock formed from layers of sand, Glacial ice is formed from layers of sky. As the density increases, the ice becomes impermeable. It is solid. If you were to hold a piece of this deep ice, recovered from hundreds of meters down, it would feel heavy, dense, and remarkably hard. It is no longer the soft cushion of winter. It is the armor of the planet. This is the weight of time made tangible. When we stand on the surface of a glacier, we are standing on the present moment. But a few meters down, we are standing on the Industrial Revolution. A bit deeper, and we are standing on the Renaissance. Go down a mile, and you are standing on the era when humans were just beginning to migrate out of Africa. The ice sheet is a vertical timeline, preserving the past in a way that no book or hard drive ever could. This concept of deep time is humbling. In our daily lives, we measure time in seconds, minutes, hours. We rush. We are governed by the immediate. But the ice operates on a different scale. It does not care for the frantic pace of human existence. It moves and changes with a slowness that borders on stasis. To the ice, a human life is a flicker, a brief spark that vanishes in an instant. The ice measures time in compression, in the slow deformation of crystals, in the gradual thickening of the sheet. Deep within the glacier, the pressure is immense. The weight of the overlying ice, often kilometers thick, creates a crushing force that we can scarcely imagine. Yet, the ice does not break. It flows. We will speak of its movement later, but for now, focus on the static pressure. It is a holding environment. It holds the bubbles of ancient air under such pressure that if you were to drop a piece of this ancient ice into a glass of water, it would fizz and pop as it melted, releasing the pressurized atmosphere of a bygone era. You would be hearing the release of tension held for 10,000, 50,000, maybe 100,000 years. The darkness down here is absolute. Sunlight can penetrate only a few meters into the snow and ice before it is scattered and absorbed. Beyond that, there is only the deep, blue-black crushing dark. It is a silent, cold womb where the history of the earth is kept safe. There is no weather here, no storms, no changing seasons. The temperature is stable, preserved by the insulation of the ice above. It is a world of perfect preservation. Think of the fernification process as a long, slow exhalation. The snow lands, full of air and fluff, taking up space. Then, over centuries, it exhales that space, condenses. It pulls itself together, retreating from the expansiveness of the cloud into the density of the crystal. It is a withdrawal from the world of gases and fluidity into the world of solids and permanence. And in this density, there is a kind of memory. The ice remembers the temperature of the day it fell. The isotopic composition of the oxygen and hydrogen atoms in the water molecules changes depending on how cold the air was when the snow formed. By analyzing the ice, we can read the thermometer of the past. The ice creates a continuous, unbroken record of the climate, written in the language of isotopes and trapped gases. It is a library where the books are made of frozen water, and the pages are the annual layers of snowfall, pressed thin by the weight of the ages. So, the snowflake we watched fall is now gone, in a sense. It has been crushed, reshaped, fused with its neighbors, and buried in the dark. But in another sense, it is more permanent than ever. It has become part of the great cryosphere, a silent witness to the passage of time, holding its breath under the weight of the world, waiting for the slow, creeping journey that will eventually, millennia from now, return it to the sea. If you were to stand upon the surface of a great glacier, perhaps in the high silence of the Alps or the vast, flat expanse of the Antarctic plateau, the world would appear entirely motionless. The ice stretches out to the horizon, a white desert frozen in a perpetual snapshot of stillness. It feels solid, unyielding, a landscape of permanence that has forgotten the fluidity of the water from which it was born. But this is an illusion of our perception, a trick played by the disparity between the frantic pace of human life and the deep, languid rhythm of the earth. Beneath your feet, the ice is moving. It is flowing. The glacier is not a rock. It is a river. It is a river of solid water, pouring itself down the mountainside or spreading outward toward the sea with a slowness that is almost impossible to comprehend, yet possesses a momentum that is absolutely unstoppable. To understand this movement, we must return to the concept of weight. We spoke of the firn, the snow turning to ice, and the crushing pressure of accumulation. As the ice thickens, reaching depths of 50 meters, 100 meters, or even several miles, the sheer mass of the glacier becomes the engine of its own motion. Gravity, that constant, patient force, pulls at every single crystal in the lattice. It tugs at the mountain of ice, urging it downward, urging it to seek the lowest point. But how does a solid flow? How does something as hard and brittle as ice, which would shatter if you struck it with a hammer, move like honey? The answer lies in the darkness of the depths, where the pressure is greatest. Down there, buried beneath tons of overhead weight, the ice undergoes a transformation known as plastic deformation. It surrenders its brittleness. It enters a state where it is no longer rigid but viscous. It becomes a material that can bend, stretch, and fold without breaking. Imagine a deck of cards. If you push on the side of the stack, the cards slide over one another. This is similar to what happens within the crystal lattice of the deep ice. The layers of molecules, those hexagonal sheets we visualized earlier, begin to slip. They glide past their neighbors microscopic plane by microscopic plane. This internal deformation allows the glacier to change its shape, to drape itself over the landscape, to ooze around obstacles. It is a slow-motion creep, a rearrangement of the very fabric of the ice in response to the crushing weight above. This internal flow is silent and invisible from the surface. It is the secret inner life of the glacier. But there is another way the ice moves, a mechanism that happens at the very bottom, where the cold belly of the glacier meets the hard, rough skin of the earth. This is called basal sliding. Deep beneath the surface, the temperature of the ice is often not as cold as the air above. The earth itself radiates heat, a gentle warmth from the planetary core that seeps upward into the rock. And strangely, the immense pressure of the overlying ice lowers the melting point of the water. This combination, geothermal heat and pressure, creates a thin, miraculous layer of water at the base of the glacier. It might be only a few millimeters thick, a hidden film of liquid darkness. This water acts as a lubricant. It is the oil in the machine. It uncouples the ice from the friction of the rock, allowing the entire colossal mass of the glacier to slide. It is, in essence, the largest ice skating rink in the world, but instead of a person gliding on thin blades, it is a mountain of ice sliding on its own meltwater. When the glacier moves via basal sliding, it does not move silently. If you could place your ear against the bedrock, deep underground, you would hear the sound of the earth being ground down. It is a low, vibrational groan, a rumble that is more felt than heard. This is the sound of erosion. As the ice slides, it acts like a giant sheet of sandpaper. It grips rocks and boulders in its frozen base, tools it has plucked from the valley floor, and drags them along. This process is slow, terrifyingly powerful, and relentlessly consistent. The glacier scours the landscape. It shaves off the rough edges of mountains, turning jagged peaks into smooth, rounded domes. It carves U-shaped valleys that look like they were scooped out by a giant spoon. The rocks embedded in the ice scratch long, parallel lines into the bedrock, known as striations, the fingerprints of the glacier's passage. And in this grinding, the rock is pulverized. It is crushed into a fine, silted powder known as glacial flour. When this flour is eventually washed out by meltwater streams, it turns the rivers and lakes below a startling milky turquoise. That beautiful, surreal blue of a mountain lake is the direct result of the violence happening at the bottom of the glacier, the evidence of the earth being ground into dust by the weight of the ice. But the movement is not uniform. A glacier is a complex body. The ice in the center, far from the friction of the valley walls, flows faster than the edges. The ice at the surface, which is brittle and under less pressure, is carried along by the plastic flow beneath. Sometimes the tension becomes too great. The brittle surface cannot stretch as fast as the deep ice is flowing, and it cracks. These are the crevasses, deep, gaping fissures that tear open with a sudden, thundering crack. They are the stretch marks of the glacier, visible proof that the ice is under tension, that it is being pulled apart by its own momentum. There is a concept in glaciology known as residence time, the amount of time a water molecule spends locked in the ice before it reaches the end of the glacier and melts back into the ocean. For a small mountain glacier, this might be 100 years. For the vast ice sheets of Antarctica, it can be hundreds of thousands of years. The ice you see at the terminus, the imposing blue wall crumbling into the sea, fell as snow when human civilization was in its infancy. It has spent millennia flowing in the dark, sliding over continents, inching its way toward this final release. The speed of this journey varies wildly. Some glaciers are sluggish, moving only a few centimeters a day, a pace so slow that it would take a lifetime to notice the change. Others are surging glaciers, capable of lurching forward tens of meters in a single day, a sudden, chaotic acceleration that can shatter the surface into a chaos of jagged pinnacles. But for the most part, the flow is steady, rhythmic, and imperceptible. It is a movement that defies our normal understanding of speed. It is motion measured in eras. To watch a glacier move, you would need to slow your own heart rate, slow your perception until a year feels like a second. Only then would you see the river of ice rippling down the valley, pouring over cliffs like a slow-motion waterfall, widening and narrowing as it navigates the terrain. There is something deeply soothing about this inexorable flow. It reminds us that movement does not require speed. Progress does not require haste. The glacier gets to where it is going inevitably. It does not rush. It does not panic. It simply surrenders to gravity and time, allowing the physics of the world to carry it forward. It flows around obstacles it cannot move, and it moves the obstacles it cannot flow around. It is the ultimate embodiment of patience. As we drift further into the sleep of the world, imagine yourself moving with the ice. Feel the weight of the centuries pressing down, the slick, wet slide of the base against the rock, the slow, plastic bending of your own form as you navigate the winding path of the valley. You are no longer in a hurry. You are part of the flow. You are moving with the majestic, heavy grace of the frozen earth, sliding toward the sea at a pace that allows you to savor every single millimeter of the journey. The friction is not a struggle. It is a connection, a way of feeling the world as you pass over it, reshaping it, leaving your mark in the stone, a testament to the power of gentle, persistent pressure. If you were to close your eyes and picture the coldest place on Earth, your mind might paint a landscape of stark, blinding white. We imagine the snow, the clouds, the frost, a monochrome world devoid of saturation. But if we look closer, if we peer into the deep crevasses or stand at the foot of a calving glacier, we discover that the true color of the frozen world is not white at all. It is blue, not the pale, reflected blue of the sky, but a deep, resonant, electric blue that seems to glow from within the ice itself. It is a color so vivid, so unearthly, that it feels as though it belongs to another planet. This color is not a pigment. You cannot scrape it off or bottle it. It is a phenomenon of light and time, a visual echo of the density we spoke of earlier. To understand this blue, we must follow a ray of sunlight as it strikes the surface of the frozen world. When sunlight hits fresh snow, it encounters a chaotic jumble of crystals and air. The snowflakes are intricate, with millions of tiny mirrored surfaces facing in every direction. The light bounces. It strikes a crystal, reflects to another, then another, and is almost immediately sent back out toward your eye. Because the light has not traveled far inside the snow, and because it is reflected equally across the entire visible spectrum, we see it as white. White is the color of scattering. It is the color of light that has been turned away at the door. But glacial ice is different. Remember the compression? Remember the weight that squeezed out the air bubbles and fused the crystals into a solid, dense mass? This density changes the rules of engagement for the light. When a photon of sunlight strikes the surface of solid, bubble-free ice, it does not bounce off. It enters. It begins a journey deep into the crystal lattice. Water molecules, whether liquid or solid, have a very specific appetite for light. The chemical bond between the oxygen and hydrogen atoms, that same hydrogen bond that creates the lattice, vibrates at a frequency that matches the red end of the light spectrum. As the white sunlight travels through the ice, the red wavelengths are absorbed. They are taken in by the ice, their energy converted into a microscopic vibration, a tiny, imperceptible warmth. The ice is hungry for the red, the orange, the yellow. It swallows the colors of fire and heat, but it has no appetite for the blue. The shorter wavelengths of the spectrum, the blues, the indigos, the violets, are allowed to pass through unharmed. They travel deeper and deeper, penetrating meters into the glacier. With every centimeter they travel, more of the red is stripped away, leaving the remaining light purer, cooler, and bluer. Eventually, this light strikes something deep within, a tiny imperfection, a grain of dust, or perhaps the bedrock itself, and is scattered back toward the surface. When it finally emerges and reaches your eye, it carries the story of its journey. It is blue because it is a survivor. It is the light that the ice could not hold. The deeper the light travels, and the denser the ice it travels through, the more intense the color becomes. This is why ancient ice is the bluest of all. Ice that has been under pressure for 10,000 years has almost no air bubbles to scatter the light prematurely. It is optically clear. Looking into a crevasse in Antarctica is like looking into a well of sapphire. The blue transitions from a light, airy turquoise near the surface, where the sun still touches it, to a rich, dark aquamarine, and finally, in the deepest recesses, to a twilight indigo that borders on black. It is a gradient of history. The darker the blue, the older the water. There is a profound stillness in this color. It is not a shouting color. It is a humming color. Feels heavy. When you look at a piece of this deep ice, perhaps a chunk of an iceberg that has washed up on a black volcanic beach in Iceland, it looks like a jewel. These diamond beach icebergs are sculpted by the sea, polished until they are smooth as glass. You can look right into them. You can see the internal fractures, the suspended bubbles, the veins of clarity. And in the center, there is that glowing, radioactive blue heart. It is a strange sensation to realize that the color you are seeing is, in a way, the color of water's true nature. We usually think of water as clear, colorless. But that is only because we typically see it in small quantities, in a glass, in a raindrop. In those small amounts, the absorption of red light is too weak for our eyes to register. But give water enough depth, give it enough mass, and it reveals its true identity. It is, and always has been, blue. The glacier simply concentrates this truth, freezing it into a solid form that we can touch. Sometimes the palette of the cold offers other surprises. While blue is the dominant hue of the deep ice, we can also find stripes of green, gray, and brown. These are the layers of the world's memory. A stripe of gray might be a layer of volcanic ash from an eruption that darkened the sky 5,000 years ago. A band of brown might be dust blown from a distant desert during a particularly arid century. But the most mysterious is the jade iceberg. Occasionally, sailors in the Southern Ocean report seeing icebergs that are a deep emerald green. For years, this was a mystery. We now believe it comes from marine ice that forms on the underside of an ice shelf, freezing directly from the seawater. This water is rich in organic matter, in yellow-tinted dead plankton and dissolved minerals. When you mix the intrinsic blue of the ice with the yellow of the organic matter, nature paints with a new color, green. These emerald giants are rare, wandering ghosts of the ocean, carrying the biological history of the sea in their frozen architecture. Yet we always return to the blue. It is the color of silence. Psychological studies have shown that the color blue slows the human heart rate. It lowers blood pressure. It induces a state of calm. It is no coincidence that the most relaxing places on Earth, the ocean, the sky, the glacier, are bathed in this hue. Imagine yourself now walking through an ice cave. We will explore these cathedrals later, but for now, focus on the light. The walls are thick, translucent ice. The sun is outside, above you, pressing against the roof of the cave. But the light that filters through to you is filtered, softened. You are bathed in an ethereal, aquatic glow. It is like being underwater, but you can breathe. The air is still and cold. The light does not cast hard shadows. It wraps around you, filling every corner with a soft, ambient luminescence. It is a light that feels old. It has traveled through centuries of snowfall to reach you. In this blue world, the visual noise of life fades away. There are no jarring reds, no urgent yellows. There is only the cool, calming spectrum of the ice. It is a visual lullaby. The ice absorbs the heat, absorbs the noise, absorbs the frantic colors of the day, and gives back only this peaceful, deep azure. It reminds us that beauty in nature often comes from subtraction. The ice takes the complex, white light of the sun and subtracts the warmth, leaving behind the cool. It takes the chaotic fluff of the snow and subtracts the air, leaving behind the clarity. It is a process of refinement, of distilling the world down to its most essential elemental state. As you drift deeper into relaxation, let this color fill your mind's eye. Visualize a vast, undulating field of blue ice stretching out under a twilight sky. It is not cold in a way that shivers. It is cold in a way that refreshes. It is a cool hand on a fevered forehead. It is the color of a deep, dreamless sleep, waiting to wrap you in its quiet, sapphire embrace. When we think of the cryosphere, we often imagine a world of perfect silence. And it is true, the silence of a snowy landscape is profound, a dampening of the world's clamor that we have already explored. But if you listen closely, if you tune your ear to the frequency of the ice, you will discover that the frozen world is not mute. It has a voice. It sings, it groans, it whispers. It is a symphony of stress and release, played out on instruments made of water and air. The songs of the glacier are the sounds of physics in motion. The most common sound, familiar to anyone who has spent time near a large ice sheet, is the calving crack. But before that dramatic finale, there is a deep, resonant groaning. This is the sound of the ice stretching. As the glacier flows over uneven terrain, a hidden ridge of bedrock, a sudden drop in the valley floor, the ice is subjected to immense tension. It is being pulled apart. The groans you hear are the sounds of the crystal lattice reaching its breaking point, millions of tons of ice adjusting its weight. It sounds like thunder, but deeper, more visceral. It is a sound that you feel in your chest as much as you hear with your ears. It is the earth itself shifting in its sleep. But there are subtler, stranger sounds. If you were to stand near a frozen lake in the spring, as the temperature fluctuates between day and night, you might hear the ice singing. This phenomenon is caused by the expansion and contraction of the ice sheet. As the ice warms in the sun and cools at night, it builds up internal stress. When this stress is released, it sends a vibration traveling through the ice. Because the ice acts as a giant soundboard, similar to the body of a violin or a guitar, these vibrations are amplified and modified. The result is a laser-like pew-pew sound, a futuristic electronic noise that seems completely out of place in the natural world. It can sound like a synthesizer or a stone skipping across a taut metal wire. These are dispersion sounds. The high-frequency sound waves travel faster through the ice than the low-frequency ones. So, if you are standing at a distance from the source of the crack, the high notes reach you first, followed rapidly by the lower notes, creating a descending, whistling chirp. It is a ghostly, beautiful melody, a song sung by the lake to the empty air. In the deep ocean, the icebergs have their own acoustic signature. As an iceberg drifts into warmer waters, it begins to melt. This melting releases the ancient air we spoke of earlier, the air trapped in the fernification process thousands of years ago. This is called Bergy seltzer. As the bubbles pop, they make a fizzing, crackling sound. It is the sound of a million tiny time capsules opening at once. If you are in a kayak near an iceberg, not too close, of course, the air is filled with this constant frying pan sizzle. It is the whisper of the past being released into the present. But the most haunting sounds come from the singing icebergs. Sometimes, water flows through cracks and tunnels within a massive iceberg. As the waves of the ocean push water in and out of these cavities, the iceberg acts like a giant organ pipe. The air inside is compressed and released, creating a low-frequency hum or a mournful moan. These sounds are often below the range of human hearing, infrasound, but they can be detected by sensors thousands of kilometers away. Whales and other marine life likely hear these songs clearly, a constant, shifting background track to their lives in the deep. Researchers in Antarctica have recorded the sound of the Ross Ice Shelf singing in the wind. The surface of the shelf is covered in snow dunes, which act like obstacles to the steady polar winds. As the wind blows across the rough surface, it causes the entire ice shelf, a slab of ice the size of France, to vibrate. It hums. The pitch of this hum changes depending on the temperature and the strength of the wind. When the surface melts slightly in the summer, the pitch drops. It is a seismic song, a continuous monitoring of the ice's own health, broadcast into the bedrock below. There is also the sound of ice quakes or cryoseisms. These occur when water seeps into cracks in the ground or the glacier and freezes. Because water expands when it freezes, it exerts tremendous pressure on the surrounding rock or ice. In the dead of night, when the temperature drops sharply, the pressure becomes too great and the ground ruptures. It sounds like an explosion, a sharp, terrifying crack that can shake the foundations of houses in the far north. It is the frost expanding its territory, breaking the earth to make room for itself. Yet, despite this orchestra of cracks, groans, whistles, and hums, the dominant acoustic quality of the ice is still silence. The sounds are punctuation marks in a long, unwritten novel of quiet. On the Antarctic plateau, arguably the quietest place on Earth, the background noise is almost non-existent. There is no rustling of leaves, no chirping of birds, no hum of traffic, no running water. If the wind dies down, the silence is absolute. It is a heavy silence, presses against your ears. In this absence of sound, you can hear the blood rushing in your own veins, the rhythm of your own heart. This silence is not empty. It is expectant. It is a clean slate. In our noisy lives, our brains are constantly filtering out information, deciding what to ignore. But in the acoustic vacuum of the ice, the brain can rest. There is nothing to filter. There is only the vast white stillness. It is a sensory deprivation tank on a planetary scale. Listening to the ice is a form of meditation. It requires patience. The glacier does not perform on command. You must wait. You must sit in the cold and let your breathing slow down. And then perhaps you will hear it. A distant boom, a subtle sizzle, a melodic chirp. These sounds remind us that the ice is not dead matter. It is active. It is responding to the sun, the wind, the ocean, and the earth. It is a living system, constantly adjusting, constantly seeking equilibrium. Even the falling snow has a sound if you listen closely enough. It is a soft, friction-filled whisper as the flakes brush against each other and land on the ground. It is the sound of a blanket being pulled up, a gentle hush that signals the world to sleep. So, Let us listen to the frozen world. Let us hear the deep bass rumble of the moving glacier, the high electronic song of the lake ice, the fizzing whisper of the melting iceberg, and the mournful hum of the wind over the shelf. These are the songs of the Earth's cooling system, the lullabies of the cryosphere. They are songs without words, played on a scale that dwarfs us, echoing through the cold, clean air of the poles, telling a story of endurance, transformation, and the majestic, slow passage of deep time. If you were to look at the Earth from the bottom up, centering your gaze on the South Pole, you would see a massive, radiant shield of white dominating the southern hemisphere. This is the southern giant, the Antarctic ice sheet. It is a feature of our planet so vast, so heavy, and so permanent that it alters the rotation of the Earth itself. To step onto this continent is to leave the biological world behind and enter a realm where ice is the only geology, the only biology, the only reality. The sheer scale of the Antarctic ice is difficult to hold in the mind. It covers 14 million square kilometers, an area roughly the size of the United States and Mexico combined, buried under a continuous blanket of frozen water. But it is not the width that is most staggering. It is the depth. We are not talking about a thin crust of frost. We are talking about a vertical ocean. On average, the ice here is over 2 kilometers thick. In its deepest basins, specifically in the Wilkes subglacial basin, the ice plunges to a depth of nearly 5 kilometers, 3 miles of solid, compressed time pressing down into the crust. Imagine standing on the surface of the East Antarctic Plateau. You are standing on ice that is so thick that if you were to drill down, you would pass through snow that fell during the Roman Empire, then through ice that formed when the pyramids were raised, then deeper into layers that saw the end of the last ice age, and finally, miles down, you would reach ice that fell as snow nearly 1 million years ago. You are separated from the actual Earth, the bedrock, by a vertical timeline of human and pre-human history. This immense weight has a profound physical effect on the continent below. The ice is so heavy that it has crushed the land. The bedrock of Antarctica has been pushed down by the sheer mass of the water above it, in a process known as isostatic depression. Whatever mountains or valleys existed there before the big freeze have been humbled, pressed down thousands of meters into the mantle. If the ice were to magically vanish in an instant, the continent would slowly, over tens of thousands of years, rebound, springing back up like a slow-motion mattress recovering from a sleeper's weight. But for now, the land sleeps under the burden, held in place by the white hand of the giant. Because of this ice, Antarctica is the highest continent on Earth. But it is a ghost altitude. When you stand at the South Pole, you are at an elevation of nearly 3,000 meters, over 9,000 feet. The air is thin and cold, not because of the rock beneath you, but because you are standing on a mountain of ice. You are walking in the sky supported by water. The conditions here are the closest we can get to another planet without leaving our own. It is the coldest, driest, and windiest place on Earth. The temperatures in the interior can drop below -80 degrees Celsius. At these temperatures, boiling water thrown into the air instantly vaporizes and turns into ice crystals before it hits the ground, creating a hissing cloud of white dust. Your breath freezes on your face. The moisture in your eyes can turn to frost. It is a cold that feels heavy, a physical presence that presses against you, demanding stillness. Yet, despite being covered in water, this is a desert. The polar plateau receives less precipitation than the Sahara. The air is so cold that it cannot hold moisture. The snow that does fall, often just a few centimeters a year, is not like the fluffy flakes of a temperate winter. It is diamond dust, tiny, needle-like crystals that drift out of a clear, blue sky. They sparkle in the sun like glitter, creating halos and sundogs, optical phenomena that ring the sun with rainbows. This dust does not melt. It lands, it settles, and over centuries, it becomes part of the sheet. This isolation is protected by the Southern Ocean and the circumpolar current, a continuously moving loop of water that circles the continent, effectively cutting it off from the warmer waters of the north. It is a thermal moat. Inside this moat, the continent has been frozen for over 30 million years. Think about that span of time. 30 million years of winter, 30 million years of silence. While the rest of the world saw the rise and fall of mammals, the shifting of continents, and the greening of forests, Antarctica has remained a white, silent sentinel, keeping the world's climate in balance. Buried beneath this ice are secrets that we are only just beginning to discover. One of the most haunting is the Gamburtsev mountain range. These are the ghost mountains of Antarctica. They are a mountain range the size of the European Alps, with peaks and valleys and jagged ridges, completely buried beneath the ice of East Antarctica. No human eye has ever seen them. We know they are there only because of radar surveys that can peer through the ice. They have been encased in their frozen tomb for millions of years, preserved perfectly, safe from the erosion of wind and rain. It creates a strange duality, a flat, featureless plane of white on the surface, hiding a dramatic, rugged landscape of peaks in the dark below. The ice here flows as all ice does, but on a massive scale. It moves outward from the high interior toward the coast, feeding the vast ice shelves that float on the ocean. The Lambert Glacier, for instance, is the largest glacier in the world, a river of ice over 400 kilometers long and nearly 100 kilometers wide. It drains about 8% of the Antarctic ice sheet. To see it from space is to see a texture of flow, a slow-motion pouring of the continent into the sea. But there are parts of the giant that do not flow to the sea. In the McMurdo Dry Valleys, we find one of the few places in Antarctica not covered by ice. Here, the transantarctic mountains block the flow of the ice sheet, and the fierce katabatic winds, gravity-driven winds that fall from the high plateau at hurricane speeds, scour the valley floors, evaporating any snow that falls. These valleys are a landscape of bare rock, frozen soil, and hypersaline lakes. They are the closest earthly analog to the surface of Mars. The silence here is different. It is the silence of stone and dust, a dry, mummified silence that feels older than the ice itself. Even the sky above the giant is unique, because the ice is so clean, so pure, and the altitude is so high, the atmosphere is incredibly stable. This makes it the perfect window into the universe. Astronomers flock to the South Pole to observe the cosmic microwave background radiation, the afterglow of the Big Bang. And deep within the ice, physicists have built the Ice Cube Neutrino Observatory. They have melted strings of sensors deep into the clear, dark ice to detect ghostly particles called neutrinos passing through the Earth. The ice of Antarctica is not just a geological feature. It is a scientific instrument, a lens used to study the origins of the cosmos. There is a profound peace in thinking about the East Antarctic ice sheet. It is the stable heart of the cryosphere, While the West Antarctic ice sheet is marine-based and more vulnerable to warming, the East is a fortress. It sits high and dry on the continental bedrock. It is a reservoir of stability. It holds enough fresh water to raise global sea levels by over 50 meters, a sleeping potential energy that commands respect. As we drift over this landscape in our minds, imagine the texture of the surface. It is not perfectly smooth. It is sculpted by the wind into sastrugi, hard, wave-like ridges of snow that look like a frozen, choppy sea. These ridges can be knee-high or waist-high, hard as concrete, aligned with the prevailing wind. They are the dunes of the ice desert. And on a larger scale, there are megadunes, gentle undulations in the surface that are invisible from the ground but sprawl for kilometers, created by centuries of wind interaction. This is the domain of the southern giant, a place where the land has surrendered to the water and the water has surrendered to the cold. It is a place where time is stored in layers, where mountains are ghosts, and where the silence is as thick as the ice itself. It is the anchor of our world, a heavy, white counterweight at the bottom of the globe, spinning slowly in the dark, keeping the planet steady, keeping the history of the Earth locked safe within its cold, blue vaults. If we were to drift upwards from the South Pole, following the magnetic lines of the Earth across the equator and into the northern hemisphere, we would find the counterpart to the southern giant. It is smaller, yes, but no less majestic. This is the northern crown, the Greenland ice sheet. While Antarctica feels like a separate planet, isolated by the swirl of the Southern Ocean, Greenland feels like the guardian of our own history, a vast, white witness standing at the gateway to the Arctic. Greenland is a bowl of ice. The geography here is unique. The island is ringed by coastal mountains, a jagged rim of rock that holds the interior ice in place. Over millions of years, the weight of the ice has depressed the center of the island, creating a vast basin that sits below sea level. The ice sheet fills this basin and spills over the mountains, a reservoir of cold that is 3 times the size of Texas. To stand in the center of Greenland is to stand on a high, white plain that curves gently away in every direction, a perfect dome of silence under the midnight sun. But unlike the dry, frozen desert of the Antarctic interior, the Greenland ice sheet is a landscape of active water. In the summer months, a transformation occurs that is both haunting and beautiful. As the sun beats down on the surface, the top layer of snow and ice begins to melt. It does not turn to slush. It liquefies into water of the most startling, impossible blue. These are the superglacial lakes, sapphire jewels scattered across the white expanse. They are ephemeral, existing only for a season. They form in the depressions of the ice, collecting the meltwater from 1,000 tiny rivulets. From the air, they look like eyes opening on the face of the glacier. The water is terrifyingly clear, devoid of life, devoid of sediment, pure liquid cold. This water, however, does not stay still. It seeks a path down, carves winding, serpentine rivers into the surface of the ice. These rivers meander just like their counterparts on land, cutting deep canyons into the glacier with smooth, polished walls of blue glass. They flow for miles, sliding silently over the frictionless ice until they find a weakness. And here we encounter one of the most mesmerizing features of the Northern Crown, the moulin. A moulin, named after the French word for mill, is a vertical shaft, a drainpipe drilled by the water straight down into the heart of the glacier. When a river meets a moulin, it vanishes. It plunges over the edge in a thundering, internal waterfall, disappearing into the darkness of the ice. Imagine standing at the edge of one of these shafts. The sound is a deep, reverberating roar, echoing up from the depths. The water is falling hundreds, sometimes thousands of meters, straight down to the bedrock. It carries the heat of the sun into the cold belly of the glacier. When it hits the bottom, this water spreads out, lifting the entire ice sheet slightly, lubricating the base, and speeding up the flow of the ice toward the sea. It is a hydraulic system of immense power, hidden entirely from view. Yet, there is a quiet detail on the surface of Greenland that speaks to the delicate balance of this world. If you look closely at the ice in the ablation zone, the area where melting occurs, you will see that it is not perfectly white. It is speckled with dust. This is cryoconite. It is a fine, gray powder composed of dust from Asian deserts, soot from wildfires, particles from volcanoes, and even micrometeorites from outer space. It is the fallout of the world, caught by the sticky surface of the wet ice. But this dust is alive. Each tiny grain of cryoconite is a home for microscopic life, bacteria, algae, and tardigrades. These darkened spots absorb more heat from the sun than the surrounding white ice, causing them to melt faster. They drill tiny, cylindrical holes into the surface, creating cryoconite holes. Each one is a miniature ecosystem, a water-filled test tube containing a universe of microbes that live, reproduce, and die in the frozen silence. From a distance, they make the ice look gray and weathered, a testament to the fact that even here, in the freezing cold, life finds a way to colonize the void. The ice of Greenland is also a library. Because the snowfall here is heavier than in Antarctica, the layers are thicker, and the record is more detailed. Deep cores drilled into the Greenland summit have revealed the chaotic climate history of the Northern Hemisphere. They tell the story of the Dansgaard-Oeschger events, sudden, violent swings in temperature that occurred during the last ice age, where the world warmed by 10 degrees in the span of a single human lifetime. The ice remembers these fevers. It remembers the Vikings who settled on the green coastal fringes during a warm period, only to vanish when the cold returned and the ice expanded. The Northern Crown is also the birthplace of giants. While Antarctica creates vast, flat tabular icebergs that look like floating islands, Greenland produces the jagged, cathedral-like mountains of ice that drift into the North Atlantic. The glaciers here are fast. The Jakobshavn Glacier on the west coast is a river of ice moving at a sprinting pace for a glacier, sometimes flowing 40 meters a day. It is a conveyor belt of ice, pushing millions of tons of frozen water out into the fjord every year. It is widely believed that the iceberg that sank the Titanic was born here, calved from the face of a Greenland glacier, drifting for months or years before its fateful meeting in the dark. There is a particular acoustic quality to the Greenland fjords. These are deep, narrow inlets carved by the ice, where the mountains rise steeply from the water. When a glacier calves into a fjord, the sound is trapped. It bounces back and forth between the rock walls, amplifying the roar. But afterwards, the silence that descends is heavy. The water in the fjord is often calm, protected from the open ocean swells. It reflects the glacier like a mirror. You can float there in a boat, suspended between the white walls of ice and the black water, in a stillness that feels religious. Under the ice of Greenland, scientists have recently discovered something extraordinary: a massive impact crater. Hidden beneath the Hiawatha Glacier in northwest Greenland is a depression 31 kilometers wide, the scar of an iron asteroid that slammed into the Earth perhaps as recently as 12,000 years ago. For millennia, the ice has hidden this wound, smoothing over the surface, filling the crater with frozen water. It is a reminder that the ice protects the Earth not just from the weather, but from the evidence of catastrophe. It heals the landscape, burying the violence of the past under a blanket of white. As we visualize this northern realm, let us focus on the light. The light in the Arctic is different from the Antarctic. It is softer, often diffused by low clouds and fog. In the summer, the sun dips low toward the horizon but never sets, bathing the ice sheet in a perpetual golden hour that lasts for weeks. The shadows stretch out, long and purple, across the snow. The ice glows with a soft, peach-colored light. It is a time of endless day, a time when time itself seems to lose its meaning because the cycle of night and day has been broken. And in the winter, the northern crown sits under the aurora borealis. The green and violet ribbons of light dance over the ice, reflected in the dark mirrors of the frozen lakes and the black waters of the fjords. The ice sheet, silent and vast, sits beneath this cosmic display, a white canvas for the energy of the sun. The silence of the aurora, some say they can hear it crackle, but mostly it is a visual song, matches the silence of the ice. It is a conversation between the magnetosphere and the cryosphere, played out in the dark. Greenland is a place of transition. It is where the ice meets the inhabited world. Unlike Antarctica, which is surrounded by storm-tossed oceans, Greenland is close to the continents. Its cold breath chills the winds that blow over Europe and North America. It is the refrigerator of the North, a cooling presence that we feel even when we are thousands of miles away. It is a reminder that we are all connected to the ice, that the Northern Crown is not just a distant wonder, but a vital organ of the living planet. So, let the image of the blue meltwater rivers flowing over the white ice lull you. Picture the water spiraling down into the Moulin, a journey into the dark, secret heart of the world. Picture the dust of the stars resting in the cryoconite holes. This is the active, breathing, flowing ice of the North, a landscape of profound beauty and gentle, persistent change, watching over the top of the world as it has done for eons. We have spoken of the ice that clings to the land, the heavy blankets that smother continents, and the rivers of solid water that carve through mountain ranges. But there comes a moment in the life of every glacier when it must leave the safety of the Earth. It reaches the edge of the sea. Here, at the terminus, where the white cliff meets the dark, churning water, the glacier undergoes a profound transformation. It sheds its tether to the ground and births a wanderer. This is the origin of the iceberg, the wandering cathedral of the frozen world. The birth of an iceberg is known as calving. It is a term borrowed from biology, suggesting a natural, life-giving process, though the scale is anything but gentle. Imagine standing on the deck of a ship, a safe distance away, watching the face of a tidewater glacier. The wall of ice might be 10 stories high, a jagged, fractured mosaic of white and blue. For a long time, nothing happens. The glacier seems static. Then, a deep, gunshot crack echoes across the water. A fissure races down the face of the ice, faster than the eye can follow. And then, slowly at first, a massive section of the wall begins to lean, tilts outward, surrendering to gravity. With a majestic, terrifying slowness, millions of tons of ice detach and crash into the sea. The splash is monumental. It sends a tsunami of spray and displaced water radiating outward. But then, something miraculous happens. The ice does not sink. It rises, buoyed by the density difference between the fresh frozen water and the salty liquid ocean. The newborn iceberg bobs to the surface, rocking back and forth, seeking its equilibrium. It is a chaotic few minutes as the giant finds its footing in this new element. But eventually the rocking slows, the waves subside, and the iceberg settles into a stillness that will define the rest of its existence. It is now a ship without a rudder, a traveler without a destination. It has become a pelagic entity, belonging to the open ocean. These icebergs come in all shapes and sizes. Some are growlers, small chunks the size of a piano that lurk low in the water, dangerous and hard to see. Others are burgy bits, the size of a small house. But the true cathedrals are the tabular icebergs of the Antarctic, massive, flat-topped islands of ice that can be larger than some small countries. They have vertical cliffs rising hundreds of feet out of the water, sheer walls of blinding white that seem to go on forever. But as magnificent as these walls are, they are a deception. We have all heard the phrase, the tip of the iceberg, but to truly understand the physics of the cold, we must visualize what lies beneath. The density of glacial ice is about 900 kilograms per cubic meter, while seawater is slightly denser, at around 1,025 kilograms per cubic meter. This small difference dictates the architecture of the iceberg. It means that roughly 90% of the iceberg's mass must be submerged to support the 10% we see. Imagine the underwater portion. If the part above the water is a 10-story building, the part below is a skyscraper stretching down into the abyss. This submerged keel is often sculpted into fantastic shapes by the currents. Arches, caverns, and long, protruding spurs of ice that reach out into the darkness. It is a hidden mountain, drifting silently through the deep. The water down there is dark and cold, and the pressure is immense. Yet the ice holds its shape, a ghost ship navigating the underwater currents. Because of this deep draft, icebergs are not driven primarily by the wind. A strong gale might whip the ocean surface into a frenzy, pushing sea ice and small boats in one direction, but the great iceberg will move in another, driven by the deep, slow currents that flow hundreds of meters below the surface. They plow through the sea ice, unstoppable, indifferent to the surface weather. They are piloted by the deep ocean itself. As they drift, these wandering cathedrals begin to change. They are entering warmer waters. The air is no longer the freezing embrace of the polar plateau. It is moist and salty. The sun is stronger. The erosion begins. It is a slow, sculptural process. The waves lap at the waterline, carving a notch into the base of the iceberg. Over time, this notch deepens, creating a precarious overhang. Eventually, the weight of the overhang becomes too great, and the ice collapses, changing the center of gravity. The entire iceberg rolls over. This rolling is a momentous event. An iceberg that has been white from snow accumulation suddenly flips to reveal its underside. And this underside is often a glassy, translucent blue, or perhaps the deep jade green we spoke of earlier. It is ice that has never seen the sun, ice that has been polished by the friction of the water. When an iceberg flips, it is like a new sculpture being unveiled. It emerges dripping, pristine, and dazzlingly clear, a jewel of the ocean. There is a distinct ecosystem that travels with these wanderers. They are not just dead blocks of ice, they are life rafts. The water immediately surrounding a melting iceberg is rich in nutrients. As the ice melts, it releases the iron and mineral dust it trapped millennia ago on the continent. This creates a halo of fertilization. Phytoplankton bloom in the nutrient-rich wake of the iceberg, turning the water green. These microscopic plants attract krill, which in turn attract fish, seabirds, seals, and whales. An iceberg is a floating oasis in the often desert-like expanse of the open ocean. It carries its own food web, a traveling biological hotspot. The sounds of the iceberg are continuous. We mentioned the Bergy seltzer, the popping of ancient air, but there is also the sound of the water interacting with the ice. Waves crashing into an ice cave at the waterline create a booming, resonant drumbeat. Water dripping from the melting spires creates a rhythmic, musical plinking. In the quiet of a foggy morning, an iceberg sounds like a living thing, breathing, cracking, and sighing as it slowly returns to the liquid state. Their journey can be incredibly long. Some icebergs from Antarctica can drift for years, circling the continent in the coastal current before being ejected north into the iceberg alley of the Atlantic. They can travel thousands of miles, crossing lines of latitude, moving from the polar night into the temperate sun. As they move north, they become weathered. They lose their sharp edges. They become rounded, fantastical shapes. Castles with melting turrets, bridges of ice that span nothing but water, mushrooms of ice balanced on thin stalks. These are the phantom ships reported by sailors for centuries. In the mist, a weathered iceberg can look startlingly like a sailing vessel with white canvas sails. They appear and disappear in the fog, silent and ghostly. They are the white whales of the ocean, moving with a ponderous, heavy grace. Eventually, the thermodynamics of the world catch up with them. The water becomes too warm. The structure weakens. The cathedral begins to crumble. It breaks apart into smaller and smaller pieces, Bergy bits, then growlers, then simply slush. The end of an iceberg is a dissolution. It is a return. The water molecules that were locked in the crystal lattice for 10,000 years, that traveled across a continent, that fell as snow when mammoths walked the earth, are finally released. They mix with the salt water. They become part of the ocean again. They will evaporate, form clouds, and perhaps, one day, fall as rain on a green forest or as snow on a distant mountain range. The cycle completes itself. The wandering cathedral does not die. It simply changes state. It goes from being a solid monument of time to being a fluid part of the present. There is a gentle melancholy in watching an iceberg melt. It is a reminder of the transience of all things. Even the hardest, coldest, most massive structures eventually yield to the warmth. They soften. They lose their boundaries. They merge with the greater whole. It is a peaceful surrender, a long, slow fade into the blue embrace of the sea. As you drift with these thoughts, Imagine yourself on the deck of a ship in the twilight. The sea is calm, a mirror of dark water. Ahead of you, a great white shape rises from the gloom. It is glowing with a faint, inner light. It is silent, save for the soft lap of water against its flanks. It is passing you by on its own timeline, on its own journey. You watch it until it disappears into the mist, a white ghost returning to the ocean that birthed it, leaving behind only the cold, fresh scent of ancient snow in the air. We have traveled across the surface of the ice, watched the snow accumulate into firn, and followed the glaciers as they calved into the sea. Now we must turn our gaze downward once more, but this time we are going deeper than the ice itself. We are going to a place that shouldn't exist, a place that defies our intuition about the frozen world. We are descending into the hidden, liquid heart of Antarctica. Imagine standing on the bleak, wind-scoured surface of the East Antarctic Plateau, near the Russian research station Vostok. The temperature here is often minus 80 degrees Celsius. It is a desert of ice, lifeless and still. But if you were to look down through nearly 4 kilometers of solid ice, a vertical distance greater than the height of Mount Fuji, you would not find rock. You would find water. You would find Lake Vostok. This is the largest known subglacial lake in the world, a body of water the size of Lake Ontario, buried in total darkness. It has been sealed off from the atmosphere for perhaps 15 to 25 million years. Think about that span of time. The water in this lake last saw sunlight when Antarctica was likely still covered in forests, before the great ice sheets thickened and choked the continent. It is a fossil lake, a pristine sample of Earth's water from an epoch long before humans walked the planet. The existence of liquid water under such intense cold seems like a paradox. How can a lake survive beneath miles of ice without freezing solid? The answer lies in the delicate balance of thermodynamics we touched on earlier. The ice above acts as a colossal insulating blanket, trapping the heat radiating from the Earth's core. This geothermal warmth, rising from the bedrock, meets the base of the ice sheet. At the same time, the crushing weight of the 4 kilometers of ice lowers the melting point of the water. Pressure, in this extreme environment, forces the ice to become liquid. So, in the eternal blackness, there is a lake. It is not a stagnant puddle. It is a dynamic, living body of water. It has tides, raised by the pull of the moon and the sun, just like the oceans. The surface of the lake, which is actually the bottom of the ice sheet, rises and falls by a few centimeters every day. It has currents driven by the heat from below and the melting of the ice above. The water circulates slowly, mixing oxygen and nutrients in a perpetual, silent cycle. The conditions within Lake Vostok are alien to our surface experience. The pressure is immense, over 350 times the atmospheric pressure at sea level. The water is supersaturated with oxygen, delivered by the melting of the air-rich glacial ice above. In fact, the oxygen levels are 50 times higher than in a normal freshwater lake. This unique combination of high pressure, high oxygen, and total darkness makes it an environment unlike any other on Earth. For decades, scientists knew of the lake's existence only through radar echoes. The radar waves would penetrate the ice, bounce off the water, and return a signal that was startlingly flat and clear. It was a mirror in the deep, but the lake remained a ghost, a theoretical construct. It was the ultimate look but don't touch scenario. To drill into it would be to risk contaminating one of the most pristine environments in the solar system with surface bacteria and drilling fluids. The tension of this exploration is palpable. For years, a Russian drilling team worked at Vostok Station, slowly coring their way down. They stopped just a few meters above the lake's surface, terrified of breaching the seal. It was like standing outside a sealed tomb, knowing that the air inside was breathable but potentially deadly to the outside world, or that the outside world was deadly to it. Finally, they pierced the interface, allowing the lake water to rush up into the borehole and freeze, capturing a sample without contaminating the main body of the lake. What they found in that accretion ice, the ice formed from the lake water refreezing onto the bottom of the glacier, was astounding. It contained genetic traces of life. Yes, life exists in the dark. In the cold, crushing depths of Lake Vostok, there are bacteria. These are not monsters of the deep, but microscopic survivors. They are extremophiles, organisms that have adapted to live in conditions that would kill almost anything else. They likely feed on minerals from the bedrock or organic matter released from the melting ice. They live in a slow, dark ecosystem, separated from the sun by miles of ice and millions of years. This discovery changes everything. It suggests that life is far more resilient than we ever imagined. If life can survive here, in the cold, dark, high-pressure environment of a subglacial lake, could it not also survive in the subsurface oceans of Jupiter's moon Europa or Saturn's Enceladus? Lake Vostok is a terrestrial analog for these alien worlds. It is a testbed for our understanding of life in the universe. But Vostok is not alone. Radar surveys have revealed a network of hundreds of subglacial lakes scattered across Antarctica. Some are small, like ponds. Others are vast. And they are not isolated. They are connected. We now know that there are rivers flowing beneath the ice sheet. Water moves. When a lake fills up from geothermal melting, the pressure builds until it bursts, sending a pulse of water rushing through subglacial channels to the next lake downhill. These outburst floods can travel for hundreds of kilometers, unseen and unheard, deep beneath the surface. It is a hidden hydrological cycle, a plumbing system for the continent that operates entirely in the dark. Imagine the sound of such a river. It would not gurgle like a brook. It would be under such immense pressure that it would likely flow silently, a laminar sheet of water forced through cavities in the rock and ice. Or perhaps, when the pressure releases, it roars with the force of a bursting dam, a subterranean thunder that vibrates through the soles of your feet if you were standing on the ice miles above. There is something deeply comforting about the persistence of this water. It refuses to be frozen, finds a way to flow. Even under the greatest weight, even in the coldest place, fluidity remains. It is a reminder that the Earth is active, that heat is still rising from its core, fighting the cold of space. Consider the Gamburtsev subglacial mountains we mentioned earlier. In the valleys between those buried peaks, there are lakes. Imagine a landscape of mountains and lakes, completely preserved in ice, like a ship in a bottle. The water in these valleys has been there since the ice sheet formed. It is water that has forgotten the sky. The color of this water, were you to shine a light on it, would likely be crystal clear. Without algae or sediment from surface runoff, it would be purer than distilled water. It is fossil water. It contains the chemical signature of the ancient climate. It holds the dissolved gases of the atmosphere from the time of the dinosaurs' extinction or the rise of mammals. As we drift deeper into sleep, let your mind rest on the image of this hidden network. Picture the dark, silent lakes, the slow-moving currents in the deep, the microscopic life clinging to existence in the cold. It is a world within a world. It is a secret kept by the ice. There is a concept in geology called the cryotic state, the state of being frozen. But here we see that the cryosphere is also a guardian of the liquid state. The ice protects the water. It seals it in, keeping it safe from evaporation, safe from the chaotic weather of the surface. Think of Lake Vostok as a giant, dark eye staring up at the bottom of the ice. It watches the slow, grinding passage of the glacier above it. It feels the weight of the years. It is a place of absolute solitude. No wind disturbs its surface. No sunlight warms its waves. It exists in a state of permanent, pressurized peace. And in that peace, time moves differently. The water molecules you visualize in that lake might circulate once every 1,000 years. The bacteria might divide once every century. It is a slow, slow life, a life paced by the geological heartbeat of the planet. Let this slowness seep into you. Let the heavy, dark comfort of the subglacial world wrap around your thoughts. You are safe here, deep beneath the ice, protected by the weight of the world, floating in the quiet, liquid dark of the hidden lakes. We have explored the movement of the ice, the hidden waters beneath it, and the wandering giants of the sea. Now, we must turn our attention to the ice as a keeper of secrets. We are entering the silent archives of the earth. If you were to walk into a certain cold room in Copenhagen, or Denver, or Tasmania, you would find yourself surrounded by shelves. But these are not shelves of books. They are shelves of silver canisters, and inside each canister lies a long, perfect cylinder of ice. These are the ice cores, the frozen manuscripts of our planet's history. To understand the value of an ice core, we must first appreciate the difficulty of retrieving it. Imagine a team of scientists on the high plateau of Greenland or the remote domes of Antarctica. They are living in tents or small, isolated stations, miles from the nearest comfort. They set up a drill rig, a tall tower that stands against the blinding white horizon. The drill is a hollow tube tipped with razor-sharp cutters. It spins. It bites into the surface. With a slow, rhythmic grinding, the drill descends. It cuts a circle around a column of ice, isolating it from the rest of the sheet. Then, with a mechanical heave, the core is broken free and winched up to the surface. When it emerges into the light, it is a revelation. It is a cylinder of history, perhaps 10 centimeters across and a few meters long. It is translucent, sometimes cloudy with bubbles, sometimes clear as glass. It is heavy. It is the physical manifestation of a timeline that goes down, meter by meter, into the deep past. The scientists treat these cores with the reverence reserved for holy relics. They are handled with gloved hands, protected from the warmth of human breath, and immediately placed into cold storage. They are cut into sections, labeled, and shipped across the world to freezers that mimic the temperature of the ice sheet. This chain of cold must never be broken. If the ice melts, even for a moment, the history is lost. The gases escape. The chemistry blurs. The pages of the book are washed blank. But what are we reading in these frozen cylinders? The most obvious feature visible to the naked eye is the layering. In the upper parts of the glacier, where the weight hasn't yet crushed everything into uniformity, you can see the annual bands. There is a layer of winter snow, fine-grained, wind-packed, dense. Then there is a layer of summer snow, coarser, perhaps slightly melted and refrozen, lighter in density. These alternating bands are like the rings of a tree. We can count them. We can point to a specific layer and say, this is the snow that fell in the year 1816. And in that specific layer, we might find something extraordinary. 1816 was known as the year without a summer. Crops failed, frost struck in July, and Lord Byron wrote darkness-filled poetry. The ice core tells us why. Embedded in that layer of ice is a faint, dark band of tephra, volcanic ash. It is the chemical fingerprint of the eruption of Mount Tambora in Indonesia. The volcano threw so much ash and sulfur into the stratosphere that it dimmed the sun. The ice caught that ash, preserved it. By analyzing the glass shards in the ash, we can match them perfectly to the rock of Tambora. The ice connects a famine in Europe to a volcano in Asia, bridging the gap with a single frozen line. But the true magic of the ice core lies in the invisible. It lies in the bubbles. As we discussed, the transition from snow to ice traps tiny samples of the atmosphere. These bubbles are time capsules. When a scientist places a slice of this ice in a vacuum chamber and melts it, the ancient air is released. We can measure the concentration of carbon dioxide, methane, and other greenhouse gases directly. We don't have to guess what the air was like 10,000 years ago. We have a sample of it. We can breathe the air of the mammoth steppe. From these tiny bubbles, we have reconstructed the heartbeat of the planet's climate. We have traced the rise and fall of CO2 over the last 800,000 years. We see a sawtooth pattern, long, slow descents into ice ages, followed by sharp, rapid climbs into warm interglacial periods. The ice shows us that the Earth breathes. It has a rhythm, a cycle of deep freezes and thaws that is governed by the tilt of the planet's axis and the shape of its orbit around the sun. But the ice records more than just temperature. It records the wind. By measuring the amount of dust in the core, we can tell how stormy the planet was. During the height of the last ice age, the cores are full of dust. The world was dry, windy, and cold. Deserts expanded, and dust storms raged across the continents, depositing their load on the ice sheets. The ice remembers the storminess of the Pleistocene. It also records the sun. Beryllium-10 is a rare isotope produced by cosmic rays hitting the atmosphere. When the sun is active, its magnetic field shields the Earth from these rays, and beryllium-10 levels drop. When the sun is quiet, the levels rise. By measuring this isotope in the ice, we can reconstruct the cycles of solar activity over thousands of years, tracking the sunspots and solar flares that no human eye ever saw. There is a particular beauty in the way these cores are analyzed. In the lab, a continuous melter system is used. A stick of ice is slowly lowered onto a heated plate. The meltwater from the center of the core, the purest part, is drawn off and sent through a battery of lasers and mass spectrometers. It is a continuous stream of data. As the ice melts, the numbers on the screen scroll backward in time. We watch the Roman lead pollution appear and disappear. We watch the radioactive fallout from nuclear testing in the 1960s spike and then fade. We watch the Industrial Revolution begin. One of the most profound things the ice tells us is about sudden change. For a long time, we thought climate change was always slow. But the Greenland cores revealed flickers, moments when the climate jumped. The Dansgaard-Oshkosh events we touched on earlier show that the climate can switch modes in a matter of decades. The ice shows us that the system is sensitive, that it can tip. It is a warning written in the language of isotopes. But let's step back from the data and return to the object itself. Imagine holding a piece of this deep ice. It is often incredibly clear, devoid of the fractures and imperfections of surface ice. Feels dense like a rock. If you hold it up to the light, you might see a cloudy band, a layer of hoar frost that formed on the surface of the glacier 20,000 years ago during a particularly cold, clear night. You are looking at a frozen moment of weather. The deepest ice cores, drilled at Dome C in Antarctica, go back 800,000 years. This is the Epica core. But the race is on to find the million-year core. Scientists believe that in certain pockets of Antarctica, where the ice is very thick and the geothermal heat is very low, there may be ice that is 1.5 million years old. This is the holy grail of glaciology. Finding it would connect the current climate cycles to an older, different rhythm of the Earth, helping us understand why the ice ages became so intense. These archives are fragile. The warehouses where they are stored are kept at -30 degrees. If the power fails, the history melts. There is a backup, of course, the ice sheet itself. But the ice sheet is changing. As the world warms, the surface of the glaciers is melting. The meltwater percolates down, scrambling the signal, erasing the annual layers. The library is catching fire. We are racing to read the books before the pages dissolve into water. There is a specific sound associated with the ice cores. It is the sound of the air hydrate crystals decomposing. In the very deep ice, the pressure is so great that the air bubbles actually disappear. The gas molecules are forced into the crystal lattice of the ice itself, forming a new material called a clathrate hydrate. When this ice is brought to the surface, the pressure is released. The hydrates become unstable. If you leave a piece of deep core on the table, it will slowly turn white as the bubbles reform. It will click and pop. It is the sound of the ice decompressing, the sound of the atmosphere expanding back into its natural state after being crushed for 500,000 years. So, the ice core is not just a scientific tool. It is a vessel of time. It holds the breath of the world from eras we can barely comprehend. It connects the fire of the volcanoes to the dust of the deserts and the cold of the poles. It is a continuous, unbroken narrative of our planet's life, written in water and air, waiting in the dark and the cold for us to learn how to read it. We have walked the high plateaus of the continents and drifted with the icebergs in the deep currents. Now, let us lower our gaze to the surface of the sea itself. Imagine standing on the deck of a ship in the high Arctic as autumn gives way to winter. The sun dips below the horizon, not to rise again for months. The temperature plummets, and the ocean, that vast, restless, chaotic body of water, begins to do something extraordinary. It begins to breathe. Sea ice is the skin of the polar oceans. Unlike the glaciers, which are born from snow falling on land, sea ice is born from the water itself. It is a transformation of the liquid ocean into a solid continent, a continent that grows and shrinks with the rhythm of the seasons, a breathing chest of white expanding and contracting over millions of square kilometers. The birth of sea ice is a mesmerizing, almost oily process. When the temperature of the seawater drops to around -1.8 degrees Celsius, slightly colder than fresh water due to the salt, tiny crystals begin to form. These are not the snowflakes of the air. They are fragile ice. They are microscopic, needle-like crystals that float in the top few millimeters of the water column. As they multiply, millions upon millions of them, they give the water a greasy, matte appearance. This is called grease ice. If you were to look at the ocean in this state, the waves would look strange. They would be sluggish. The grease ice dampens the small capillary waves, smoothing the surface. It looks like a heavy, dark soup. The ocean is being quieted. The friction of the wind can no longer whip it into a frenzy. As the temperature drops further, the grease ice coalesces. In calm waters, it forms a thin, elastic crust known as nylus. Nylus is dark, bending with the swell of the ocean without breaking. It looks like a sheet of dark rubber stretched over the sea. But as it thickens, it turns gray and then finally white. In rougher seas, the fragile ice clumps together into circular disks. These are pancake ice. Imagine a sea covered in thousands of white lily pads, each one raised at the edges where they bump into one another. They drift and grind together, a vast mosaic of frozen circles gently rotating in the swell. Eventually, these pancakes freeze together into a solid sheet, locking the ocean surface in place. But here is the magic of sea ice. It is a purification process. When salt water freezes, the crystal lattice of the ice has no room for the salt ions. The ice rejects the salt. It squeezes it out. As the crystals lock together, they push the brine, the salty, concentrated water, into tiny channels and pockets between the ice grains. This brine is heavy. It is dense with salt and cold. So, it begins to migrate downwards through the ice, seeking the ocean below. It trickles through microscopic veins in the ice, a gravity-driven drainage system. By the time the sea ice is a few months old, it has lost most of its salt. If you were to melt a piece of multi-year sea ice that has survived a summer melt and hardened over several winters, you could drink the water. It would be fresh. This drainage leads to one of the most otherworldly phenomena in the frozen world, the brinacle. It is sometimes called the icy finger of death. Though in our sleepy exploration, let us think of it as a stalactite of the deep. Imagine looking beneath the sea ice. The water is clear and dark. From the ceiling of ice above, a plume of supercooled, hypersaline brine begins to descend. Because this brine is much colder than the surrounding seawater, it causes the water around it to freeze instantly. A hollow tube of ice forms around the descending plume. It grows downward, a fragile, crystalline finger reaching for the seafloor. It looks like a white, hollow icicle growing in real time. It extends meter by meter, silent and ghostly. When it finally touches the seafloor, the brine pours out, flowing over the sand and rocks. Because it is so cold, it freezes everything it touches. Starfish and urchins on the seabed are encased in a tomb of ice as the river of cold flows over them. It is a slow-motion freeze, a delicate, deadly connection between the surface ice and the ocean floor. This process of salt rejection drives the heartbeat of the world's oceans. The cold, salty water that drains from the sea ice is incredibly dense. It sinks, plunges straight down to the bottom of the ocean, creating a massive downward current. This is the engine of the thermohaline circulation, the global conveyor belt of ocean currents. The formation of sea ice in the Antarctic and the Arctic drives the movement of water around the entire planet. The Gulf Stream, the currents that warm Europe, the nutrient flows in the Pacific, they are all connected to this silent sinking of brine at the poles. The sea ice is the heart that pumps the lifeblood of the ocean. There is a profound difference between the first-year ice and the multi-year ice. First-year ice is chaotic. It is jagged, filled with pressure ridges where the wind has smashed the flows together. It is salty and relatively soft. But multi-year ice is the aristocrat of the frozen ocean. It has survived. It has been flushed of its salt. It is harder, bluer, and much thicker, sometimes 3 or 4 meters thick. When multi-year ice flows collide, they create pressure ridges that can tower meters into the air. These are the mountain ranges of the sea ice. They are treacherous to cross, a chaotic jumble of blocks the size of cars. But beneath the surface, the keels of these ridges extend deep into the water, acting like sails for the ocean currents to grab onto. The soundscape of the sea ice is unique. It is not silent. It is a constant conversation between the ice, the wind, and the water. The ice squeaks. It groans. When the temperature changes rapidly, the ice cracks with a sound like a whip crack or a distant rifle shot. In the spring, as the ice begins to break up, the flows grind against each other, creating a low, rumbling growl that can be heard for miles. But perhaps the most peaceful aspect of sea ice is its effect on the swell. If you are on a ship entering the pack ice, the rolling of the vessel stops. The waves disappear. The ocean becomes a solid floor. The horizon, which was once a moving line, becomes steady. The world stops rocking. There is a visual phenomenon here called ice blink. If you are sailing in open water and looking toward the horizon, you might see a bright, white glare on the underside of the clouds. This is the reflection of the sea ice, miles away, mirrored in the sky. It is a map in the clouds, telling sailors where the frozen world begins. The sea ice also blooms. In the spring, the underside of the ice turns brown and gold. This is the ice algae. It grows on the bottom of the flows, soaking up the returning sunlight. It is the meadow of the polar ocean. Krill and amphipods graze on this upside-down pasture. It is the foundation of the entire polar ecosystem, a garden growing on the ceiling of the sea. As we drift away from this image, think of the Polynyus. These are areas of open water surrounded by ice, kept open by upwelling currents or strong winds. In the dead of winter, these are the oases. The steam rises from the relatively warm water into the freezing air, creating sea smoke. Whales and seals gather here to breathe. It is a chimney in the roof of the ocean, a place where the sea exhales its heat into the dark polar night. The sea ice is a seasonal lung. In the winter, it expands, covering the ocean in a white blanket, reflecting the sun, cooling the planet. In the summer, it retreats, exposing the dark water to the warmth. It is a slow, rhythmic breathing that has continued for millions of years. It is a reminder that even the solid ice is part of a fluid cycle, a constant negotiation between the cold of space and the warmth of the earth. Let the image of the grease ice smoothing the waves lull you. Picture the fragile crystals drifting in the dark water, the Neelas bending gently with the swell, the brinnacle reaching down with its icy finger. It is a world of slow, crystalline growth, a quiet, freezing architecture that covers the restless ocean in a blanket of peace. We have drifted on the currents of the ocean and stood atop the miles-high ice of the poles. Now let us step off the ice and onto the land. But this is not the land you might know, the soft, yielding soil of a garden or the sandy warmth of a beach. This is the cryosol, the frozen earth. This is the domain of permafrost. To walk on the tundra in the high Arctic or the vast expanses of Siberia is to walk on a deception. In the summer, the surface is green. Mosses, lichens, and tiny, resilient flowers carpet the ground. The air is filled with the buzzing of insects and the calls of migratory birds. The ground feels spongy, like walking on a thick, wet mattress. But this is only the active layer. It is a thin skin of life, perhaps only half a meter deep, that thaws for a few brief months each year. Beneath this thin skin lies the true reality of the North. Dig down just a little way, past the roots of the dwarf willows, past the peat, and your shovel will hit something that feels like concrete. It is rock hard, unyielding, and cold. This is the permafrost. It is soil, rock, and sediment that has been bound together by ice for at least 2 consecutive years, but often for thousands or even hundreds of thousands of years. Think of it as the planet's freezer. It covers nearly a quarter of the exposed land surface of the northern hemisphere. It is a vast, subterranean empire of ice-cemented earth, stretching beneath the forests of Canada, the steppes of Russia, and the mountains of Tibet. In some places in the far north of Siberia, this frozen layer plunges nearly a mile deep into the crust. It is a monument to the last ice age, a lingering cold that the warmth of the Holocene has not yet been able to touch. The permafrost is not a lifeless block of stone. It is a complex, structural architect. Because water expands when it freezes, the ground here is constantly moving, heaving, and cracking in slow motion. This creates a landscape of geometric beauty known as patterned ground. If you view the tundra from a drone, you will see vast networks of polygons, hexagons, and pentagons of soil outlined by wedges of ice. They look like a giant paved walkway laid down by titans. These are ice wedges. An ice wedge begins as a tiny crack in the frozen ground during the bitter cold of winter. When spring comes, meltwater runs into the crack and freezes. The next winter, the cold widens the crack and more water enters. Over centuries, this wedge grows, pushing the soil aside, creating these raised rims and sunken centers. It is a landscape shaped entirely by the thermal contraction of the earth itself. In the boreal forests, where the trees try to grow on this shifting foundation, we see the drunken forests. Because the permafrost prevents deep roots, the black spruce and larch trees must spread their roots sideways in the shallow active layer. When the ice below shifts or melts slightly, the ground tilts. The trees lean, some to the left, some to the right, creating a chaotic, dizzying woodland that looks like it is staggering in the wind, even when the air is still. It is a slow-motion dance of the flora, balancing on the back of the ice. But the most profound secret of the permafrost is its ability to preserve. The cold, dark, low-oxygen environment of the frozen soil stops the clock of decay. Bacteria cannot function here. Decomposition halts. What falls into the permafrost stays there, suspended in time, perfectly kept. This is the realm of the Pleistocene Park. Deep within the frozen banks of the Yukon or the coastal cliffs of Siberia, the giants of the past are still sleeping. We have found woolly mammoths with their shaggy coats still intact, the red hair still soft to the touch. We have found steppe bison with the blue brilliance of vivianite, a mineral formed by the reaction of iron and phosphate in the wet soil, coating their bones. One of the most famous sleepers is Blue Babe, a steppe bison found in Alaska. He had been lying there for 36,000 years. Yet, when he was found, the claw marks of the lion that killed him were still visible on his hide. The preservation was so complete that the scientists could determine what he had eaten for his last meal. He was not a fossil turned to stone. He was mummified meat and skin, held in the suspended animation of the cold. We have found ancient horses, cave lion cubs that look like they are merely napping, and ground squirrels curled up in their burrows, still clutching the seeds they gathered in a summer 30,000 years ago. In 2018, scientists found a microscopic worm, a nematode, in the Siberian permafrost. It had been frozen for 42,000 years. When they warmed it up in a petri dish, it moved. It ate. It was alive. It had merely been paused, waiting for the interglacial warmth to return. This concept of cryptobiosis, hidden life, challenges our understanding of death. In the permafrost, the line between living and non-living blurs. Seeds of the narrow-leafed campion, a delicate flower, were found in the burrow of an ancient squirrel, frozen for 32,000 years. Scientists were able to extract tissue from the fruit and grow a flower. A plant from the Ice Age bloomed in a modern laboratory, opening its white petals to a sun that was tens of thousands of years older than the one it was born under. The permafrost also holds the Yodoma. This is a special type of permafrost, extremely rich in organic carbon. It is essentially frozen compost, roots, grass, animal remains, and peat that accumulated during the lush summers of the Pleistocene and were flash frozen by the dust storms we saw in the ice cores. This soil is 80% ice by volume. If you were to walk on an eroding cliff of Yodoma, you would smell it. It has a distinct, earthy, pungent scent. It smells of old life. It smells of a barnyard from 10,000 years ago. It is the scent of history thawing out. There is a sound to the permafrost, too. It is the sound of the thaw slumps. As the climate warms and the ice wedges melt, the land collapses. It creates amphitheater-like craters where the mud slides down, exposing the ancient ice walls. You can hear the dripping of water, the squelch of mud, the occasional plop of a clod of earth falling into a meltwater pool. It is the sound of the freezer door being left ajar. But let us focus on the stillness. Deep down, below the active layer, the temperature is stable. It is a constant -5 or -10 degrees. It is a world of absolute, unwavering consistency. The bones of the mammoths are cradled in the ice-rich silt, protected from the scavenging beetles, protected from the weathering wind. They are waiting. For the indigenous peoples of the north, the Inuit, the Nenets, the Gwich'in, the permafrost is the cellar. It is where they store their food. A hole dug into the ground is a natural refrigerator that never fails or never used to. It is a relationship of trust with the ground. The earth provides not just the food, but the means to keep it. Imagine the sheer volume of history locked in this frozen soil. It is a planetary archive of DNA. Every gram of permafrost contains the genetic fragments of the ecosystem that once thrived there. By sequencing the DNA found in the dirt, we can reconstruct entire landscapes that no longer exist. Forests of spruce and birch that grew where there is now only tundra, herds of horses and camels that roamed the high Arctic. We don't need the bones. The ghost of the animal is in the dirt itself. There is a gentleness to this preservation. It is not the violent fossilization of a dinosaur trapped in a mudslide. It is a slow, cold embrace. The animal dies, the snow covers it, the cold penetrates it, and the ice claims it. It becomes part of the cryosphere. It becomes geology. As you visualize this frozen earth, imagine the roots of the modern plants reaching down. They hit the hard barrier of the permafrost and turn sideways, weaving a mat that holds the land together. It is a delicate balance. The ice supports the land insulates the ice. Think of the Pingo. Pingo is a hill with a heart of ice. It forms when a lake drains and the saturated ground freezes. The expanding ice pushes the earth up, creating a conical mound that can be hundreds of feet high. It is a blister on the landscape, an ice-cored volcano that grows slowly, year by year. Inside, it is pure, clear ice. From the outside, it is just a hill covered in grass. It is a secret mountain, hiding its true nature beneath a cloak of soil. The permafrost is the ground's memory of the winter that never ended. It is the cold storage of the biosphere, holding the soft tissues, the DNA, the seeds, and the stories of the world before us. It lies there, silent and hard, a vast, frozen foundation beneath the feet of the north, holding the past in its icy grip, perfectly still, perfectly preserved, waiting for the long, slow turn of the geological wheel. The frozen world is not merely a surface to be walked upon. It is a volume to be entered. We have stood on the high plateaus and drifted over the deep oceans, but now we must find an opening. We are looking for a portal, a break in the white wall that leads into the interior. We are entering the cathedrals of crystal, the ice caves that wind their way through the belly of the glaciers. To step into an ice cave is to leave the familiar world behind entirely. It is a transition from the blinding, omnidirectional whiteness of the surface to a realm of shadow and filtered light. It feels like stepping inside a massive, sleeping gemstone. The air changes instantly. The biting wind of the glacier's surface, which scours the skin and brings tears to the eyes, vanishes. In here, the air is still. It is cold, yes, but it is a damp, heavy cold that feels protective rather than aggressive. It smells of wet stone and ancient water, a scent that is clean and mineral. Most ice caves are born from the flow of water. As summer meltwater streams carve their way across the surface of a glacier, they eventually find a moulin, that vertical drain pipe we spoke of earlier. They plunge down, carrying heat into the ice. Over time, this water widens the cracks, sculpting long, winding tunnels at the base of the glacier. When winter comes and the water flow slows or stops, these tunnels remain, empty and waiting. They are the arteries of the glacier, drained of their blood, left open for us to explore. The walls of an ice cave are not smooth like a man-made tunnel. They are organic, textured, and infinitely complex. Often, they are scalloped. Imagine the surface of a giant golf ball covered in concave dimples. This pattern is created by the movement of warm air currents swirling through the cave in the summer. The air licks the ice, carving out these small, rhythmic depressions. When you run your gloved hand over them, they feel polished, slick, and undulating. It is a tactile record of the wind's breath. But the defining feature of the ice cave is the light. The ceiling of the cave can be tens of meters thick, yet it is not opaque. It acts as a massive natural skylight. The sun beats down on the surface of the glacier high above, and the light fights its way down through the crystal lattice. As it travels, the red wavelengths are stripped away, absorbed by the hungry hydrogen bonds. What arrives in the cave is a purified, ethereal blue. It is an aquamarine glow that seems to come from everywhere and nowhere. It bathes the cave in a twilight that feels underwater. You are walking on the bottom of a frozen sea, looking up at the surface. Sometimes, if the ice is thin enough, you can see the shadow of a bird flying over the glacier above you, a fleeting dark shape in the blue ceiling. If the ice is thick and old, the light is a deep, resonant indigo, a color so saturated it feels heavy on the eyes. And in the corners, where the walls are thickest, the shadows are not black, but a dark, bruised violet. In some places, the ice is so clear that it disappears. You might think you are looking at a hole in the wall only to reach out and touch a solid, glass-like barrier. These are windows into the glacier's past. Suspended in this glass, you can see the debris of the mountain. Rocks the size of houses that were plucked from the bedrock centuries ago, hovering in midair, frozen in the act of falling. You can see streaks of black volcanic ash, the stratigraphy of the Earth's volatile history, painted in suspended layers. Not all ice caves are carved by water. Some are carved by fire. In Iceland or on the Kamchatka Peninsula in Russia, glaciers often sit on top of active volcanoes. Heat rises from the earth. Fumaroles and hot springs vent steam directly into the base of the ice. This creates a cave that is melted from the bottom up. These are the fire and ice caves. The interplay of elements here creates a fantastical palette. The steam melts the ice, but the cold refreezes it, creating dripping stalactites of ice that hang like chandeliers from the ceiling. The walls can be multicolored, streaked with the yellow of sulfur, the red of oxidized iron, and the black of basalt ash, all encased in the blue ice. It is a stained glass cathedral, lit by the sun above and the heat below. Consider the acoustics of these spaces. An ice cave is a quiet place, but it is rarely silent. Drips. In the summer, the sound is a constant, musical rain. Drops of meltwater fall from the ceiling into pools on the floor, creating a rhythmic plink, plink, plink that echoes down the tunnel. It is the ticking clock of the cave. Each drop is a tiny piece of the ceiling returning to the liquid state. The sound reverberates off the hard, curved walls, amplifying into a soft, resonant hum. If you speak, your voice is swallowed by the ice, dampened and softened, stripped of its harsh edges. There is a profound sense of transience in an ice cave. This architecture is temporary. A cave that exists this winter may be gone next winter. The glacier is moving, remember? It is sliding and deforming. The cave is being carried down the valley. The ceiling will eventually collapse, or the tunnel will be crushed by the weight of the ice, or the river will return and flood the space. To stand in an ice cave is to stand in a fleeting moment. It is a limited edition landscape. You are seeing a room that the Earth has built for just a brief instant in geological time, a room that will never exist in quite the same way again. In Antarctica, on the slopes of Mount Erebus, the southernmost active volcano on Earth, there are ice caves of a different breed. Here, the heat from the volcano vents steam that freezes instantly as it hits the -30-degree air. This builds towering chimneys of ice, hollow towers that rise 10 meters into the air. Inside these towers, the warm, moist air creates a humid, tropical microclimate. Mosses and algae grow in the dark, warm soil around the vents, while just a few feet away, the world is locked in a deep freeze. These caves are life support systems, huddled around the volcanic hearth. The floor of an ice cave is often as treacherous as it is beautiful. It might be a frozen river, a ribbon of smooth, terrifyingly slippery ice that mirrors the ceiling perfectly. Or it might be a beach of black volcanic sand, deposited by the stream. Walking here requires a slow, deliberate pace. You must trust your crampons, feeling the metal bite into the ice with a satisfying crunch. This sound, metal on ice, is the only sharp noise in the muffled world. Psychologically, the ice cave offers a return to the womb. It is an enclosed, curved space. It wraps around you. The outside world, with its chaos and noise and changing weather, is effectively gone. There is only the blue light, the drip of water, and the cold stone. It is a place of introspection. The sensory deprivation of the surface, the whiteout, is replaced by sensory enrichment. The textures, the colors, the sounds, they are all subtle, all close at hand. Imagine finding a dry spot on a rock inside one of these blue halls. You sit down. You turn off your headlamp. The darkness is not total. The faint, blue glow from the ceiling filters down, just enough to see the outline of your own hand. You listen to the glacier. You might hear a deep, low groan, the ice settling, shifting its weight. It is a reminder that you are inside a living thing. You are a guest in the belly of the beast. But the beast is slow, and it is sleeping. The air you breathe in here is perhaps the freshest on Earth. It has just been released from the ice where it was trapped for centuries. It is crisp, high-oxygen air that wakes up the lungs, feels cleansing. Every breath is a connection to the past. These cathedrals are hidden from the sky. Satellites cannot see them. To find them, you must walk the ice, look for the Mulan, look for the black gape of the portal. They are secrets kept by the glacier, revealed only to those who venture close enough to look inside. They are the private chambers of the cryosphere, where the ice reveals its inner beauty, its color, its clarity, its ability to hold light and shape it into a sanctuary of peace. As we stand on the threshold of our own atmosphere, looking up into the velvet blackness of the night sky, we realize that our journey through the frozen world has been somewhat parochial. We have been obsessed with the ice of Earth. But out there, in the vast, silent cathedral of the solar system, ice is not a rarity. It is the standard. It is the fundamental building block of the outer worlds. We live on a warm, wet rock near the fire of the sun, but the universe itself is a place of profound cold. Let us drift now, leaving the gravity of Earth behind, to visit the other frozen children of our star. Our first stop is a familiar neighbor, Mars. Through a telescope, even a modest one, you can see them, the brilliant white caps sitting atop the rust-red poles of the planet. These are the Martian ice caps, but they are a trick of the eye, a duality. The permanent cap, the part that stays all year round, is made of water ice, just like on Earth. It is a reservoir of frozen water vast enough to cover the entire planet in an ocean 11 meters deep, were it ever to melt. However, in the Martian winter, a second type of ice descends. This is dry ice, frozen carbon dioxide. The atmosphere of Mars freezes. It snows CO2. This dry ice forms a seasonal blanket over the water ice, extending the caps down toward the equator. When spring arrives on Mars, this dry ice does not melt into a liquid. It sublimates. It turns directly from a solid back into a gas. This creates violent, silent winds, jets of gas that scream across the surface at hundreds of kilometers per hour. There is a phenomenon on the Martian South Pole known as araniiforms, or more poetically, spiders. As the sunlight penetrates the translucent slab of dry ice in the spring, it heats the soil beneath. The ice sublimates from the bottom up, building pressure until the gas explodes through the crust, spraying dark dust into the air. These dark fans of dust look like black spiders scuttling across the white ice. It is an active, alien geology driven entirely by the physics of freezing and thawing gas. Drifting further out, past the asteroid belt, we cross an invisible boundary known as the frost line. This is the point in the solar system where the sun's heat is too weak to keep volatile compounds like water, ammonia, and methane in a gaseous state. Beyond this line, ice becomes as hard as rock. It becomes the bedrock of worlds. We arrive at Jupiter, the king of planets, and turn our gaze to its moon, Europa. To look at Europa is to look at a polished gemstone hanging in the dark. It is the smoothest object in the solar system. There are no mountains, no deep valleys, only a crisscrossing network of dark red lines that look like veins on an eye. This is a world completely encased in a shell of water ice, perhaps 20 kilometers thick. But Europa is not frozen solid. It is being squeezed. As it orbits Jupiter, the immense gravity of the giant planet pulls and pushes on the moon, kneading it like a ball of dough. This tidal heating creates friction deep inside the core, generating heat. This heat melts the underside of the ice shell, creating a subsurface ocean of liquid water that wraps around the entire moon. Think of it, a global ocean containing twice as much water as all of Earth's oceans combined, hidden beneath a roof of ice that has never seen the sun. The dark lines on the surface, the lineae, are cracks where the ice shell has pulled apart and water from below has welled up to fill the gap, freezing instantly. It is a tectonic system of ice. We believe that in this hidden, dark ocean, hydrothermal vents might exist on the seafloor, spewing heat and chemicals. It is one of the most promising places to look for life, swimming in the eternal night of a moon-wide sea. Further out still, we reach the realm of Saturn. Here we find Enceladus, a tiny moon, a mere gleaming snowball compared to Europa. It is the most reflective object in the solar system, reflecting nearly 100% of the sunlight that hits it. It is pure, blinding white. For years, we thought it was dead. But then the Cassini spacecraft looked back at Enceladus, backlit by the sun, and saw the plumes. At the south pole of this tiny moon, there are 4 massive fissures in the ice, dubbed the tiger stripes. They are warm. From these cracks, geysers of water vapor and ice particles are erupting continuously, shooting jets hundreds of kilometers into space. Enceladus is crying out to the cosmos. This is cryovolcanism, volcanoes that erupt ice instead of lava. The gravity of Enceladus is so weak that much of this spray escapes the moon entirely. It drifts into orbit around Saturn, creating the E-ring, a diffuse, ghostly ring made entirely of microscopic ice crystals. Saturn is wearing a necklace made from the frozen breath of its moon. And just like Europa, we believe these plumes come from a subsurface ocean. The spacecraft flew through these plumes and tasted them. They are salty. They contain organic molecules. It is a sample of a hidden sea, delivered freely into the vacuum for us to analyze. Then there is Titan, Saturn's largest moon. Titan is a strange dream. It has a thick, orange atmosphere that hides its surface. But beneath the haze, it is a world carved by liquid. There are rivers, lakes, and seas, but they are not water. The temperature here is minus 179 degrees Celsius. Water is a mineral here. It is the rock, the mountains, the pebbles on the beach. The liquid flowing into the Kraken Mare, Titan's largest sea, is liquid methane and ethane. It rains natural gas on Titan. The hydrological cycle is exactly like Earth's, but the chemistry is shifted. Imagine standing on the shore of a methane lake. The waves would move in slow motion because of the low gravity and low density of the liquid. The raindrops would be huge, falling lazily from the orange sky. The rocks under your feet would be frozen water, hard as granite, never melting. It is a familiar yet utterly alien landscape, a frozen mirror of our own home. Finally, we must acknowledge the wanderers, the comets. These are the leftovers, the scraps of ice from the formation of the solar system that were tossed out into the deep freeze of the Oort cloud, far beyond Pluto. A comet is a dirty snowball. It is a mix of water ice, dry ice, dust, and rock, tumbling in the dark for billions of years. Occasionally, a gravitational nudge sends one falling inward toward the sun. As it approaches the warmth, it wakes up. The ice begins to sublimate. It creates a coma, a glowing atmosphere of gas around the nucleus. And then, the solar wind grabs this gas and dust and stretches it out into a tail that can be millions of kilometers long. A comet is an iceberg that has grown wings of light. To watch a comet streak across the sky is to watch the death of a piece of ice. It is spending itself. With every pass around the sun, it loses mass. It sheds its skin. Eventually, after thousands of orbits, the ice will be gone, leaving only a rocky husk, or the comet will break apart entirely, vanishing into dust. There are even stranger ices out there. On Uranus and Neptune, the ice giants, the pressure deep inside is so intense that water might exist in a state called superionic ice. This is a hot, black ice where the oxygen atoms are locked in a crystal lattice, but the hydrogen atoms flow freely through them like a liquid. It is ice that conducts electricity. It is ice that is both solid and liquid at the same time, existing at temperatures of thousands of degrees. It challenges our very definition of the word. The universe, it seems, is a master of variations on the theme of cold. From the dry ice spiders of Mars to the subsurface oceans of Europa, from the methane rain of Titan to the black hot ice of Neptune, the frozen state is not a monolith. It is diverse. It is active. It is creative. As we drift back from this tour of the outer dark, let the scale of it settle in your mind. We are surrounded by ice. The solar system is a shell of cold wrapped around a tiny heart of fire. The vacuum itself is a preserver of the frozen. There, in the silence between the planets, water molecules drift alone, waiting to find a surface, waiting to join a crystal, waiting for the slow, billion-year accumulation that builds worlds. We have traveled to the ends of the Earth and the edges of the solar system, but now let us return to the very small, to the intimate physics of the water molecule itself. There is a strangeness to water, a refusal to behave like other substances, that becomes most apparent when we push it to the brink of freezing. It is a rebel in the world of chemistry, and its rebellion is what allows life to exist. Consider the phenomenon of supercooling. We are taught in school that water freezes at 0 degrees Celsius. It is a hard rule, a line in the sand. But nature is rarely so rigid. If you take very pure water, water that has been distilled, stripped of all impurities, dust, and minerals, and you cool it down slowly in a smooth container, you can trick it. You can lower its temperature to -5, -10, even -40 degrees, and it will remain liquid. This is a state of high tension. The water molecules desperately want to freeze. They want to snap into that comfortable hexagonal lattice we spoke of at the beginning, but they cannot start. To form a crystal, ice needs a seed. It needs a nucleation site, a rough edge, a speck of dust, a bubble, something to grab onto. Without that seed, the molecules aimlessly bump against each other, cold and confused, waiting for a leader. The moment a seed is introduced, perhaps a single snowflake falling into the beaker or a sudden shake of the container, the spell is broken. The water freezes instantly. It is a cascade of crystallization. The ice shoots through the liquid like a lightning bolt, turning the clear water into an opaque solid in the blink of an eye. It is a release of pent-up energy, a snap freeze that releases a small amount of heat as the bonds lock into place. It is the physics of anticipation finding its resolution. Then there is the Mpemba effect, a riddle that has puzzled thinkers since the time of Aristotle. It is the counterintuitive observation that hot water can freeze faster than cold water. It defies logic. Surely, the hot water must first cool down to become cold water, and therefore it should take longer? But the story goes that in the 1960s, a Tanzanian student named Erasto Mpemba was making ice cream. He noticed that the warm milk mixture he put in the freezer hardened faster than the cooled mixture of his classmates. He asked his physics teacher why and was mocked, but he persisted. And he was right. There are many theories for why this happens, and the debate is still a polite whisper in the halls of thermodynamics. Perhaps the hot water evaporates faster, reducing its volume so there is less to freeze. Perhaps the convection currents, the swirling movement of the hot liquid, move the heat more efficiently to the surface where it can escape. Or perhaps the heat drives out the dissolved gases, the tiny bubbles of air, changing the chemistry of the water and raising its freezing point. Whatever the cause, it is a reminder that the path from hot to cold is not always a straight line. The journey into the frozen state has shortcuts. We must also revisit the density anomaly, the most important mistake in physics. As water cools, it contracts and gets denser, just like any other liquid. This happens until it reaches exactly 4 degrees Celsius. At this magical temperature, water is at its heaviest. It sinks. This is why, in a deep lake in winter, the bottom is always 4 degrees. It is a sanctuary for fish, a stable layer that never freezes. But as it cools further, from 4 degrees down to 0, it starts to expand. It gets lighter. The molecules begin to arrange themselves into the open lattice. This is why ice floats. If water behaved correctly, like iron or oil, the ice would sink. The oceans would be filled with ice from the bottom up. The sun would never be able to melt the deep ice. Earth would be a frozen white ball, forever locked in an ice age. We owe our existence to this tiny geometric quirk of the hydrogen bond at 4 degrees. There is also a form of ice that isn't really ice at all. It is called amorphous ice. In the deep vacuum of space or in specialized labs, if you cool water down incredibly fast, at a rate of millions of degrees per second, the molecules don't have time to find their hexagonal partners. They are frozen in place instantly, right where they are. The result is a solid that looks like a liquid. It has no crystal structure. It is chaotic, disordered, random. It is essentially glassy water. Scientists believe that this is actually the most common form of water in the universe. The ice on the dust grains in interstellar clouds, the ice that makes up comets. It is likely this strange, glass-like amorphous ice. It is water that has been stopped in its tracks, a snapshot of liquid chaos preserved in solid form. Think about the sound of freezing. We talked about the crack of the glacier, but on a small scale, freezing is quiet. Yet, as the ice crystals grow, they exclude impurities. If you freeze a solution of salt water, the ice is pure. This zone refining is a cleaning process. The cold purifies. It separates the essence of the water from everything else. There is a peace in these physics. The laws of thermodynamics are not battling for dominance. They are seeking equilibrium. Heat always flows from the hot object to the cold object. It is a giving away of energy. The cup of tea on the table gives its heat to the room. The ocean gives its heat to the atmosphere. The universe is a vast system of sharing warmth, of spreading it out until everything is equal. The cold is not an active force. It is the absence of heat. It is the canvas that remains when the energy is gone. When we study the physics of cold, we are studying the art of stillness. We are watching matter slow down, stop vibrating, and settle into a state of rest. Even the pressure affects the freezing. We usually think that squeezing things makes them solid. But because ice occupies more space than water, if you squeeze ice hard enough, it melts. You can turn ice back into water just by pressing on it. This is why a wire with weights on the ends can cut through a block of ice without breaking it. The pressure melts the ice under the wire, allowing it to pass, and the water refreezes behind it. The wire passes through the block like a ghost, leaving the ice intact. These are the paradoxes of the frozen world. Hot freezing faster than cold. Solids that float on their own liquids. Pressure that melts instead of hardens. Water is a substance that loves to break the rules. As you lie there, let your own mind mimic the water. Let your thoughts slow down. Let the heat of the day, the worries, the plans, the frantic energy, dissipate into the cool air of the night. Feel yourself becoming denser, heavier, sinking into the mattress like the water at 4 degrees. You are finding your point of maximum rest. You are settling. The chaos of the liquid state is giving way to the order of the crystal. You are entering a state of suspended animation, safe, stable, and perfectly still. The story of ice is not just a story of formation. It is also a story of departure. For every snowflake that falls, For every glacier that grinds its way down a mountain, there comes a moment of release. We are entering the phase of the melt. It is easy to view melting with a sense of loss, especially in our changing world. But in the language of deep time, melting is simply the exhaling of the earth. It is the return of the lone. The retreat of a glacier is a quiet, melancholy, yet beautiful process. It begins at the terminus, the toe of the ice. The hard, blue armor softens. The sharp edges become rounded. The sun, which for centuries was reflected away by the white shield, now begins to penetrate. The ice sweats. It glistens. Listen to the sound of the melting. It is the most musical part of the cryosphere. It starts with a single drop falling from an ice cave, a distinct, sharp plink. Then, as the day warms, the drops become a trickle. The trickle finds a groove in the ice and becomes a runnel. The runnels join together to form a stream. By mid-afternoon on a summer day, the surface of a glacier is alive with the sound of rushing water. It is the sound of 1,000 tiny rivers running over glass. This water is glacial milk. It is cold, carrying the fine silt, the rock flour we spoke of earlier. As the glacier pulls back, it reveals the landscape it has been hiding for thousands of years. This is the forefield. It is a raw, gray landscape of gravel and boulders, a place that looks like the first day of creation. The rocks are scoured clean, marked with the striations of the ice's passage. There is a profound gentleness in the way the land recovers. First, the ground is bare, but slowly, life returns. The pioneer plants arrive, hardy mosses, fireweed with its brilliant pink petals, tiny willows that creep along the ground. They are reclaiming the territory. The retreat of the ice is an invitation for the green to advance. It is a slow changing of the guard. As the heavy weight of the ice is lifted, the earth itself reacts. We mentioned isostatic depression, the squashing of the continent. Now we see isostatic rebound. The land, freed from the crushing burden of billions of tons of ice, begins to rise. It is a slow geological sigh of relief. In places like Scandinavia and Hudson Bay, the land is still rising today, centimeters per year, recovering from the ice sheet that vanished 10,000 years ago. The beaches are being lifted out of the sea. The geography is rewriting itself in the wake of the cold. The melting ice also births new bodies of water. Proglacial lakes form at the foot of the retreating glacier, held back by dams of moraine, the piles of rubble left by the ice. These lakes are milky turquoise, opaque and surreal. They are the tears of the glacier. They hold the meltwater for a while before releasing it down into the valley, feeding the rivers that water the civilizations below. There is a cycle here that connects the mountain peak to the ocean trench. The water molecule that was locked in the ice crystal for a millennium melts. It flows into the stream, tumbles over waterfalls, aerating, waking up. It joins the river. It flows past forests, past cities, past fields. And finally, it reaches the sea. This return is essential. The ice sheets are the world's freshwater towers. Their melting, when it happens in the natural rhythm of the seasons, provides the flow that sustains life during the dry months. It is a generous giving. The glacier hoards the water in the winter so it can give it away in the summer. But the melting we see now is also a reminder of fragility. The orphan icebergs, Chunks of ice left stranded on the shore by the retreating tide are sculptures of loss. They sit on the black sand, shrinking hour by hour. They become translucent, their shapes twisting into swans, into arches, into abstract forms. They are beautiful in their dying. They drip onto the sand, leaving a wet mark that evaporates in the wind. They are ghosts returning to the ether. There is a Japanese aesthetic concept called mono no aware, the pathos of things. It is the appreciation of the transient, the bittersweet realization that nothing lasts forever. The melting ice is the ultimate embodiment of this. Its beauty is tied to its impermanence. If ice were as permanent as diamond, it would lose its magic. The fact that it melts, that it changes state, that it slips through our fingers is what makes it precious. Think of the Mulan again, swallowing the meltwater. In the late stages of a glacier's life, these holes become larger. The glacier becomes porous. It is rotten ice. It loses its structural integrity. It sounds like a honeycomb crumbling. It is the sound of a structure surrendering to entropy. Yet, in this surrender, there is peace. The water is not destroyed. It is liberated. It goes back to the cloud. It goes back to the rain. It goes back to the soup of the ocean. Prepares to start the journey all over again. Perhaps 1,000 years from now, that same molecule will evaporate, drift north, and fall again as snow on a new peak, beginning a new cycle of fernification. The retreat is not an end. It is a phase. The pendulum swings. The ice advances and the ice retreats. The world cools and the world warms. We are currently living in the warmth, watching the great white giants sleepily withdraw into the mountains. We are the witnesses to the melt. As you visualize the glacier receding, imagine the silence it leaves behind. The grinding of the ice stops. The heavy groans cease. The valley is left open to the sky. The wind blows over the new lakes, creating small ripples. The sun warms the gray rocks. It is a quiet aftermath, a stillness that feels ancient and new at the same time. Let go of the need for permanence. Let yourself melt a little. Let the tension in your muscles turn to liquid. Let the hard edges of your thoughts soften and flow away like the meltwater streams. You are entering the flow. You are moving with the gravity of the earth, heading towards the great, calm ocean of sleep. We have reached the final frontier of our journey. We have gone from the snowflake to the glacier, from the iceberg to the ocean, and from the physics of freezing to the melancholy of the melt. Now, we must travel to the ultimate limit. We are going to the coldest place possible, not a place on a map, but a state of being. We are approaching absolute zero. In the world of physics, temperature is just a measure of movement. Heat is vibration. The hotter an object is, the faster its atoms are jiggling, bouncing, and colliding. As we cool an object down, we are essentially stealing its momentum. We are calming it. The dance of the atoms slows. The frantic energy dissipates. We descend past the freezing point of water, 0 degrees Celsius. Past the freezing point of mercury, minus 39 degrees Celsius. Past the freezing point of carbon dioxide, minus 78 degrees Celsius. We go deeper into the realm of the cryogenic. We pass the liquefaction point of oxygen, minus 183 degrees Celsius, and nitrogen, minus 196 degrees Celsius. Here, The air itself turns into a clear, blue liquid. We keep going. We reach the temperature of deep space, the cosmic background radiation, at 2.7 Kelvin, minus 270.45 degrees Celsius. This is the baseline cold of the universe, the fading heat of the Big Bang. But we can go lower. In our laboratories, using lasers and magnetic fields, we have cooled matter to within a billionth of a degree of absolute zero. Absolute zero is 0 Kelvin, or minus 273.15 degrees Celsius. It is the theoretical stopping point of the universe. It is the moment where all thermal motion ceases. It is the ultimate stillness. At this temperature, the classical laws of physics break down and quantum mechanics takes over. Matter behaves in spooky, miraculous ways. Atoms lose their individual identity. They stop behaving like billiard balls bouncing off each other and start behaving like waves. They overlap. They merge. They form a Bose-Einstein condensate. Imagine a crowd of people running around in a stadium. That is a gas at room temperature. Now imagine everyone stopping, standing perfectly still, and then suddenly everyone merges into a single giant person. That is matter near absolute zero. The atoms sing in unison. They become a superatom. They move together with perfect coherence. Friction disappears. If you stir a fluid at this temperature, a superfluid, it will spin forever. It will never stop. It has achieved a state of eternal, frictionless flow. This is the third law of thermodynamics. It states that as the temperature of a perfect crystal approaches absolute zero, its entropy approaches zero. Entropy is disorder. So at absolute zero, we find perfect order, perfect organization, perfect peace. There is a cosmological theory known as the Big Freeze or the heat death of the universe. It sounds frightening, but in the context of our sleepy journey, it is a vision of ultimate rest. It suggests that billions of years from now, as the stars burn out and the galaxies drift apart, the universe will expand and cool until it reaches a state of thermodynamic equilibrium. The energy will be spread out evenly. There will be no more fire, no more collisions, no more noise, just a vast, cold, dark silence. It is the universe finally falling asleep. After eons of activity, of burning stars and colliding black holes, the cosmos will settle into a long, eternal slumber. It is the final stability, but we do not need to wait for the end of time to feel this peace. We can carry the concept of absolute zero within us. It is the stillness at the center of the turning world. It is the quiet place inside where the noise of life cannot reach. Think of the cold not as a deprivation, but as a clarity. Heat is messy. Cold is precise. Heat is noise. Cold is silence. Heat is vibration. Cold is stillness. When we seek sleep, we are seeking a microversion of this thermal death. We lower the lights. We cool the room. We lie still. We try to slow the vibration of our thoughts. We are trying to approach our own personal absolute zero. Imagine your body as a system cooling down. The frantic atoms of your anxiety are losing energy. They are slowing. They are no longer colliding. They are settling into a lattice of calm. You are becoming a superfluid. Your thoughts are no longer jagged and separate. They are merging into a single, smooth wave of consciousness. You are entering the deep time of the mind. The seconds are stretching out. The ticking clock fades away. You are floating in the zero-gravity, zero-friction vacuum of deep sleep. There is no resistance here, no friction to wear you down. You can glide forever. The ice we have explored, the glaciers, the icebergs, the frozen lakes, they are all just imperfect echoes of this ultimate cold. They are trying to reach it. The water molecule locks into its hexagon because it wants to stop moving. It wants to rest. The entire universe is on a slow, gravity-driven slide toward this state of perfect, crystalline stillness. And now you are there too. You have reached the bottom of the thermometer. The movement has stopped. The vibration has ceased. The world is suspended in a perfect, blue-white stasis. There is nothing left to do, nothing left to solve, nothing left to melt. There is only the quiet, the deep, heavy, beautiful quiet of the Absolute. And so, we have come to the end of our journey through the frozen archives of the world. We have watched the first flake fall from the gray sky, and we have stood in the silent heart of the Antarctic plateau. We have listened to the groans of the shifting glaciers and the whisper of the freezing sea. We have touched the ancient blue ice and felt the stillness of the permafrost. Now the ice is closing over. The white blanket is being pulled up, tucking the world in for the long night. The images of the day are freezing over, becoming still and distant, trapped under layers of soft, mental snow. The rivers of your thoughts are slowing down, turning from rushing water to sluggish streams, and finally to silent, solid crystal. You are safe here in this winter of the mind. The cold is a fortress. Nothing can disturb the deep hibernation you are entering. Like the seeds sleeping in the frozen ground, you are resting, gathering strength, waiting for the distant spring that will come in its own time. But for now, there is no need to grow, no need to move, only to be. Let the gravity of the earth hold you. Let the heavy, comforting weight of the blankets mimic the pressure of the snow. Let the darkness of the room become the darkness of the subglacial lake, peaceful and timeless. The storm outside, if there is one, cannot reach you. The noise of the world is muffled by the falling snow. You are drifting on a flat, calm sea of ice, moving slowly towards the horizon of dreams. The world has slowed down to match the beating of your heart. Drift, float, freeze, rest in the quiet, rest in the cold, rest in the deep, blue silence.